Alright, I'm going live. Huh? Yeah, this is going to be a very, very impromptu stream, and it's late, so I don't think anyone's going to kind of join. This is pretty much just going to be for my own stuff later on, if anyone does end up joining. So, but luckily I have all this stuff kind of set up from...
Yeah, so you can just do it.
Yeah, I can just jump right in and start doing. Oh, wow. Someone... What? That was quick. Sirens and Fire Alarms of Northern Florida. Hello. Hey, how's it going, man? I literally just started, so this might be kind of a... kind of boring for just a second, but, I guess pretty much as an introduction to this stream to kind of talk about kind of what I'm planning. Again, this is gonna be a bit rambly and hopefully not super long, but I'm pretty much gonna be attempting to just kind of model my. I want to try something different, and a lot of my sirens that I've modeled in the past have basically just been, I mean, you've all seen them, like the STL10 and the SD10 and stuff like that. Like, they're all just kind of modeled after, like, larger scale sirens, and they all kind of have the same inherent flaw of that they don't coast very long. I mean, the STL10, by far, out of all the sirens I've made, is the one that coasts the longest, but that's only because it's weighted, or the rotor is weighted, I should say. But, I thought it'd be kind of fun to try to take a crack at making, like a coaster siren, like a QTB, like a Q2B, or like even like a B&M CS8M7 or something like that, like, but a lot like a coaster siren in general, with a functioning clutch and everything like that, and try to make it kind of small, just like my regular sirens as well. But basically to try to see if I can experiment and try to make a coaster, because a lot of the sirens I've made, again, have been modeled after full-size sirens. I think it'd be kind of cool to send a little bit of love towards the vehicular siren crowd, because I'm definitely a collector of those as well. I honestly think that the vehicular sirens are actually just a bit more convenient for my use case, because I live in an apartment and I don't have space for a full-size siren. I mean, I have my actual SD10, but my SD10 is way back in California, because there was no way I was going to be able to bring it all the way over here. I'll probably do a video when I go back to California. I'll probably do a video on that as well, of my actual siren, my SD10. It's like a 60s. I think it's a 60s model SD10. I have the actual data tag somewhere. Hey, what's up, Abel? You're famous, man. I am not famous at all. Cool Sirens 1000T. Hello, how's it going, man? Sirens and Fire Alarms of Northern Florida. Good, yeah. Just trying to do something a little different. Hugo Lopez, hi. I don't think I've seen you before. I don't know if you're subscribed or not. I'll probably definitely check later. But, yeah, so pretty much we're just going on to try to see what we can do. And, you guys are basically going to follow along with me and kind of just, work through this as I do. And we'll see kind of what we can do. I have a couple ideas I've thought up of how I'm actually going to make the clutch to actually function properly in this this model, but we'll see what we can do. I'm your savior. No, you're not, man. No, you're not. Great, man. How about you? I'm doing all right. Just like, again, just I know it's a little bit of a late stream. At least it's late for me. It's almost 8 o'clock here. So I'm kind of starting at a reasonable time. But I guess we'll go ahead and we'll kind of jump in, and we'll get to some of the stuff I'm going to be working on. So I'm going to go ahead. This is just Streamlabs. You guys can see Streamlabs really quickly. But I guess we'll start off with Fusion. We have a fresh file in Fusion, so I can go ahead and start and do it whenever I want to. I've got up to 2 more models I can make right now. I went by and I closed off a whole bunch of other stuff just because there's a lot of stuff in here I wasn't using right now. So we'll just keep that closed and we'll kind of start off with something kind of fresh. So starting off, I guess we'll go and get some reference images first. So I guess we're going to look up a federal sign and signal Q2B. Let's see if we can find some good reference images. Of course, everyone knows what a Q2B looks like, but we'll go off of this pretty much. And there's going to be some design constraints that are going to be a bit different, that are just going to that are just basically going to be inherent with the size of the siren I'm making. I typically try to make my I typically try to make my rotors about the same size. I mean, they're pretty much all the same size, with the exception of like the Model 7T, which uses a smaller rotor than I usually do. But most of my rotors are pretty much around 50 to 40 millimeters in diameter. So we'll probably make this siren have about the same size rotor as that. So the rotor's going to be about 40 millimeters, which, if you want to see kind of what that looks like, go ahead and just open up my calipers really quick, and we'll just give you kind of like a quick little visual. So there's 40 millimeters right there. That probably is not going to come through very well on the camera, because I know that the screen that you guys are actually looking at is so tiny. But there's 40 millimeters. That's my hand. So about about over the size of about a palm of your hand. So it's going to be relatively small, at least compared to the full-size version. It's probably going to be, I don't know what kind of scale we're going for yet. But again, a couple things are going to have to be different about the actual internals in order to make it work properly. But if this prototype works, once I actually put it together and get it modeled right, if it works, then I can definitely use the clutch to make other coaster sirens. So I can make a C5, like there's a C5 right here. It's actually a C5. That might be actually either a C5 or a C6, but we'll pretty much go on from there. So yeah, we got pretty much there's not a lot of documentation I can like readily find, other than like user manuals for the Q2. There we go, that's a good image. So we can get a really good look at the rotor itself. Of course, the clutch on the full-sized Q2B is actually hidden underneath this cap. We'll go ahead and see if we can make this a little bit bigger, because these images are going to kind of suck, aren't they? Yeah, they're going to suck. Alright. But the clutch on the actual Q2B is hidden underneath that little cap. That cap's supposed to actually be brass. Guy Fieri, that's hilarious. But we'll try. We'll see what we can do. So I guess let's go ahead and first just hop into Fusion. Let me see what's going on in the chat really quick. Bailey Wycliffe says, I'm your biggest fan. Thank you, honey. That's, for those who don't know, that's my wife. Come back to the United States of Afghanistan. Alright. Sirens and fire alarms of northern Florida. You should become famous because you make miniature sirens. I mean, I'm one of the guys that makes miniature sirens. There's a lot of people that are starting to get into it more. And I hope that watching me do Fusion at least inspires some people to kind of get in there and start doing it. Oh, you guys are just having a fest in there. If the clutch works, could you try making a Sterling Y10? Definitely. That'd be kind of cool. I think that'd be really cool if I can make the clutch work. I guess I'll show you guys kind of what my idea was. So we'll go into Fusion. We'll stop kind of waffling around with the chat, and we'll get into doing some serious business. So I guess the thing I really want to primarily focus on right now is how the clutch is going to work. And my idea for this clutch is going to be a centrifugal clutch, as the regular clutches work in the Q2B. The Q2B's clutch is actually a friction style clutch. Well, I guess that's really the root of all clutches, but it basically, the way that the Q2B's clutch works is that up underneath that brass cap right here, this little section right there, there's actually a little piece of rubber, and there's a plate, and the actual rotor is like right here, and that rubber sits in between, and this plate is actually off of that rotor. And when the motor spins up, there's screw threads that are basically in this essentially like just a screw, an open-end screw. So that as the motor spins up, it screws that plate against the rotor, and that rubber washer there helps it spin the rotor up. And then when the motor stops, that screw just ends up unwinding, and that's pretty much how it ends up. That's how the clutch works in the Q2B. Some systems do it, some sirens do it differently. I believe like B&M, for example, uses actually a Sprag style clutch. Not a Sprag bearing, but it uses basically these pawls that once the motor spins up, the centrifugal force flings these pawls out as it's spinning, and it grabs the rotor, and that's what spins it. because Q2Bs have a history and a problem of them actually binding up when they actually once they get older, because that screw can't unscrew and it keeps it wound, it keeps it screwed onto the motor. My C5 has that same problem, but I fixed that recently. So we're going to head and go with something a little simple. So we're going to start out trying to make the pawl section. We're going to start off right here. This is going to have to be pretty small. You know what? Let's do the rotor first, because the rotor will kind of help me get an idea of how much space I have to work with. So let's do a 40 millimeter rotor, as we were discussing. So 40 millimeters right here. I guess we're just going to make this like a simple plate right now. So let's just make this a quick little plate. 4 millimeters, that is really thick. I don't want it to be that thick. I mean, it might have to be just a generally thicker rotor than what I'm used to doing, because I want the rotor to have some amount of weight to it, so that once the motor disengages, it'll keep free spinning. And I've got an idea of how I'm going to do that. I've got these really tiny ball bearings. It's probably not going to come up very well on the camera, but these are super tiny little ball bearings. And then these were actually what I used on the miniature Chrysler. Those are the bearings that are actually supporting the entire rotor and compressor section. So we'll do that. 40 millimeters seems to be about the kind of shape, about the size I want to go with. So we'll try that first. Just so we kind of generally know the shape we're going to be working with. Let me go ahead and make the walls of this. So 40 millimeters, we're going to make the wall thickness maybe about 2 millimeters thick for the rotor itself. We're going to go in here, just come off, so 38. This will give us our 2 millimeter wall thickness. Go up just like that. Now the Q2B has a pretty decently deep rotor. So let's see if we can find a better picture of the side. There's a side profile of it, so it's got a decently thick rotor. This is not by any means a speed run, but I definitely want to try to do this as relatively quickly as I can, just because I don't want to be sitting here for 4 hours designing this thing. So we'll see how far I can get. Now 13 millimeters from that base. Remember that the back of this rotor is 2 millimeters thick, so it's actually 15 millimeters. I also like to use a pair of calipers so I can visualize things and kind of get an idea of how thick it's actually going to end up being. Now 15 millimeters seems a little small, so we're going to do, I don't know, about 17. Well, 17 looks too big now. We'll do like 16. Oh man, that's going to be a real small siren, but if I could make it 20, I would like to do it as 20. You know what? No, we're going to do 18. We're going to go with 18. That'll be thick enough. Thick. Alright, and again, as I said, I did make the walls of this just a little bit thicker than I would normally do, because I want to make sure that this is going to have enough weight to keep coasting once it's done. Now, the one thing that's going to be kind of a pain is because of how small this clutch has to be in order to fit within the siren, and also in order to actually be detailed enough to physically work, because remember, I have to deal with the size constraints of what my printer can actually print. And this is, again, 40 millimeters for rotor sizes and stuff like that, and pretty much anything smaller in terms of functional part wise gets a little close to being on the edge of what my printer can actually print relatively detailed. So I'm going to try to make this whole siren MSLA printed, which is using my liquid resin printer. Basically is what it's using. It's not using little hard plastic filament, because that can get a lot more detail. So we're going to be kind of working with that kind of constraint, so it can probably get away with making things a little small, but I do have to keep my tolerances realistic. Chat is blowing up. My gosh, I got 8 viewers right now. That is crazy. Okay. Let's see. Abel, I don't know how to spell. You're all right, dude. You're all right. Sirens and fire alarms in northern Florida. I make mini I. The mistype. Oh, sorry about that. Abel won. Bro, Morocco lost to Portugal. I didn't see that yet. I haven't seen the game. Cool Sirens 1000T. I'm going to watch your lives because I want to learn how to make these scale sirens. Of course, man. That's what they're all here for. I have a couple other lives that are in. If you go to my go to my channel and you go over to either in playlists, I think you might be able to actually find my older lives. I believe my second live stream, my most recent one so far, is the one that if you really want to focus on how to do stuff with Fusion, look at that one, because that will teach you the basics of Fusion. Sirens and fire alarms in Northern Florida. I make miniature sirens that are not 3D printed, and I do not sell them mini sirens. Hey, it's alright. It's not for everyone. That's cool, though. AJ says hi. How's it going, man? The Ray 2009, can you make a mini Scream Master? I was thinking about making a miniature Scream Master. I was considering doing that as part of the LA series, but it would be more like San Diego. So I was like, not San Diego, but like more San Diego, Sacramento, more up north. Sirens and fire alarms in Northern Florida. If you owned a real siren besides the real sirens you already own, what would it be? Oh, I do own a real siren. Back home, I'll probably do a video on it back when I get home. To California. That's going to be the 21st is when I go back, 21st of December. But I do have a real siren. I have an SD10. On my recent video I posted that was going over the Legacy system, the Los Angeles series, that video, it's there for like just a second, but there's a picture of an SD10 and then the little miniature SD10 on top. That SD10 that's on the bottom, that's my SD10. That's back home. The Ray 2009 Long Beach has Scream Masters. Yeah, I know they're kind of scattered around California, but yeah. So we're gonna go ahead and keep this shape. We're gonna probably just rotate this because I want to be able to do this off of one side rather than doing it off just the bottom. So let's go in here. That's not the edge I want to rotate it on. Let's go here and rotate this really quick. See if I can find exactly the center. There we go. Rotate it 90 degrees. Okay. Oh, should have kept it in there so I can move it up, because I know it's going to be on one of these planes. So let's go move this above that, so I'm actually on a functional plane I can work on. Okay, good. So this is the thing that's going to be kind of a pain. So I'm going to be trying. Let's see. I'm going to give myself some level of dimensions that I can work within. So I'm going to go here and try to see if I can fit the clutch in. I want to try to make this clutch as small as possible, and I have to be realistic as well. So let's say about, it's going to be really big relative to the actual siren, which is going to kind of suck. Let's make it like 16 millimeters. So, I mean, it's definitely a lot bigger than where the clutch actually sits in the real Q. I mean, well, actually, it's not that bad. That's actually not that bad. I'm actually pretty on top of that. Oh my god, this ads, man. Worth point in internet stuff in general is so bad with ads. Let's make this about, it's way too big. I don't need that to be that deep. Let's do 13 to make sure I have enough space. Because these two bearings, I have to use two of these because the lateral play in the bearing, so the lateral play can refer to, like, say if I have a axle going through this small bearing, let's say my fingers are the bearing, this is the axle. The bearing has lateral play, I mean that the actual bearing itself can twist up to, I think, like on this one, about like 10 degrees in either direction because of just how small the bearing is. They're just not made to super high tolerance because they're already so small. And I have to account for that, so I can't use just one bearing because the weight of the rotor, once it's actually inside that stator, is going to cause the whole rotor to sag on that bearing because of the bearing's play. So I'm going to have to actually double up the bearings, so there's two of them side by side, and that will cancel out their play so it'll be nice and tight, so I can make sure that rotor stays centered in the stator so it doesn't end up scraping, because especially with the scale I'm at, the tolerance between the rotor and stator is already going to be tight enough. I don't want to risk having the thing not actually lined up properly. Speaking of which, there's a Q in the background. And that's because I live in between two fire stations. That's probably why you hear it so much. You can hear it in a couple of my other videos. But let's go ahead and measure what these two bearings are when they're butted up together. I apologize for that. These firemen love to just lay on the Q around here. They just stand on it the whole time. So if this is 13 millimeters tall, I've got 8 millimeters dedicated just to bearings, which is going to be quite a bit more than I'm really comfortable with. I might have to make this deeper. I might have to make it go all the way to the front, which is going to be really stupid, but yeah, it might just have to do that. Yeah, I might just have to deal with it. That sucks. Let's make it 18 just so it goes all the way and it's flush with the very edge of this. Okay, keep that. I want to do a section analysis really quick just so I can see kind of where I'm at when I'm actually going through this. So let's cut, I don't have a face to work off of. Let's do that one. Alright, so I can kind of get an idea of where I'm at. So I have to try to find a way to fit that clutch in just this little space, which is going to be a real drag. These bearings themselves, let me get a quick measurement, 'cause this is why it's important to have a pair of calipers to know your dimensions of the stuff you're making, if you're using parts that are not 3D printed. So my bearings themselves are 4 millimeters tall by... There's no way that's 8 millimeters. Let me re-zero my calipers. Yeah, that's what I thought. Oh no, they are, okay, yeah, they're 8 millimeters. So 4 millimeters by 8 millimeters. Okay, so 8 millimeters around, so we can go into here. We're going to go ahead and actually hollow this out so I can actually make a space for the bearings. So this is 8 millimeters around. So if I did 8 millimeters, knowing the way this printer prints, that would be way too tight. They're not gonna fit down there. Because in a perfect world, yeah, if I can print exactly to 8 millimeters, that kind of level of precision, then it'd be no problem. But the printer has its own tolerance. It has its resolution, so I do have to account for that. Now, if this rotor is going to be MSLA printed, I just know, don't ask me how I know, I've got many times of me practicing of how to actually see what the tolerance I can build to. But I have to add about 0.5 millimeters to it in order to make it open up enough to actually fit the bearing in. And even that might be a little too much. It's probably going to be a little, I mean, not enough. It's probably going to be a little tight trying to squeeze the bearing down there. But I can make a press, like a little punch that I can print to actually force the bearing down this rotor. So we're just going to do that. I'm going to say that's probably going to be pretty good. So let's go ahead and force that all the way up to the front. Make sure I have enough space to fit this bearing in there. Let's make it, that'll be fine. That'll be fine. It doesn't have to be super. So it's a 1 millimeter wall right there. So we're going to cut that. So that now means that this wall right here is 1 millimeter. Now remember, these two bearings doubled up. I can also just make a model of like a dummy bearing to kind of give me an idea of how big it's going to be, give me kind of what kind of space I have to play with. These two bearings doubled up are 8 millimeters. So, okay. So let's just say, I'll make another little sketch. We'll say that this right here, this circle, which I'll make exactly 8 millimeters, and then it's going to make it 8 millimeters tall, because that's what the bearings are when they're doubled together. Go in here, add that dimension. So let's say this right here is the bearings. So I have all of this space behind those to try to make the clutch. And that's the yikes part. That's going to be the really hard part. So we're not going to join that. We're going to keep it as like a new body. We'll go in here and we'll start labeling stuff. So my body's over here, body 1, which is the rotor itself. We'll go in here, we'll just rename this. We'll call this the rotor. And these right here, this is basically going to be a placeholder, so we'll call it placeholder. Or we'll call it a bearing placeholder, why not? Okay, so that's going to be a bearing placeholder. So then when I actually model this, that'll just keep it labeled there, so I know this is actually not part of the model, so that I can just go there and delete that. It's just so that this is just basically as a guide, so I know kind of where I'm going to be situated. Go ahead and go back to the chat really quick. I'm going to try to read some stuff really quickly. Long Beach has Screenmasters. I saw that already. Sirens and Fire Alarms in Northern Florida. Screenmasters also in San Jose. Yep. The Ray 2009 in general. What is your favorite siren? Man, you really put me on the spot there. My favorite siren. I like a lot of them. I know everyone's. I think a lot of people in the community. I think they're immediately gonna be like, "Oh, I like Thunderbolts," and I get that. But because Thunderbolts are pretty unique siren. They're a really interesting one. But I still think it's probably gonna be either like Model Ds. I've always loved Model Ds. I know they're pretty popular. I mean, they're not super popular, but they're a pretty easy to get siren. But I've always loved Model Ds. So I'd say probably Model Ds, but I'd say second to Model Ds, and really at kind of the point of like really a contender for my top siren. I would say is probably the 500s, probably the 500 SHTTs, specifically the very early ones. So like the 1950s models that you see in LA. I think those are like probably one of my favorite ones. They're really up there for me. So this is one of the ones that's going to be available on the Etsy shop soon. This is one of the ones I freshly made. This is not my personal one. You can see there's a little bit of slop in the gears. I don't know why it ended up kind of screwing up like that, but yeah, 500 SHTT for like the full size, really big sirens, and then Model D for like just like the industrial size. Out of the vehicular sirens, like the 12 volt sirens that you see on fire trucks and stuff like that, I definitely think the CS8 M7 hands down by B&M, my favorite siren of all time in terms of the 12 volt sirens. I will always love the CS8 M7. I wanted one since I was a kid. That's why I have one now. I finally got one. I got one for $300 because the guy on eBay had no idea what it was or how much it was worth. It's in rough shape, but I mean, you guys have seen videos of it. Sirens and Fire Alarms of Northern Florida. Oh, cool, you own an SD10. So you're saying you own the siren you always wanted? Kind of. Kind of. I mean, I would love to have a 500, but a 500 SHTT, but SD10 is still part of the legacy system, so it's one I'm very proud to have it. I actually got it through Eden, so I mean, all the clout goes to Eden for helping me get it. Able Wrestler 1, bro, in 10 years, I'm gonna go to Antarctica and lead an army of penguins to Greenland and invade. What are you talking about, man? They're separated by the ocean, right? They're not like, you can't march across Greenland from Antarctica, but okay. AJ, that was insane timing. I just heard a Q IRL as you did on the stream. Yeah, exactly. Sirens and Fire Alarms of Northern Florida. Does a Vixen Horns MS-190 count as a vehicular siren? MS-190. That's the. I think I actually have a one. I had a 190 a long time ago. Actually, it was one of my very first sirens that I actually ever put outside. Hold on. Give me 1 second. I'll have a picture of it actually. I'm wearing my pajamas, so don't give me any gripes about it. I'm comfy in bed, man. But yeah, I actually have a physical picture of one of my very first sirens I ever actually put outside, and it's an actual physical picture, which is even funnier. But yeah, I actually had a. This was back when they actually first came out on eBay too. But that's actually my. Let me go back to Streamlabs real quick so I can see if it's in frame. But that's actually my one of my very first little sirens. That's up on a little pole right outside my window on the side of the house. It's in between my house and my neighbor's house. But yeah, it was one of the first sirens I ever had up. My very first real siren was a a real name brand siren was actually a Model A. It was a 12 volt Model A. It was a dark olive green, and it was it was a one that was given to me. Able Rest, I'm gonna ride a killer whale. You're crazy, man. Bit finesse. I apologize for my clumsiness. I just stumbled in here. Could you give me a 20 to 30 second explanation on what's going on in this stream? I'm saying either way. Yeah. So pretty much, if you're not subscribed to my channel or you don't know who I am, I make miniature sirens. So miniature tornado sirens, air raid sirens, and in this case, I'm in the process of making a miniature fire truck siren. This, for those who don't know, or if you're unfamiliar, there's a whole community that's based around sirens in general, and like just things that make a lot of noise. And I'm in that community. We call ourselves siren enthusiasts, but the siren that you typically hear on fire trucks, for example, is actually called a federal sign and signal Q2B, which it's specific manufacturer, it's a specific model. But those are what the sirens look like. Those are the things that actually make that noise. That's what they are. So right now, I'm actually in the process of modeling a very, very small one. And I've made models in the past of full-size sirens that you would see like for tornadoes and stuff like that. I've made those in the past. I like making them just because it's a little hard to get a full-sized siren for obvious reasons because they're gigantic. And yeah, there's a lot of people in the community that like them. So this is, for example, this is a miniature tornado siren. This is an STL-10, which is made by the same company, Federal Sign and Signal. So here's an STL-10. There's the model of it. That's what it looks like on just the computer. And here is the actual model. So here is the one actually printed out and functional. They actually all work. My little models do. So, and then since I'm by a computer, I have USB right here. But here's what it sounds like. So yeah, that's what I do. There's a whole bunch of stuff on my channel if you're ever curious about it. But I make them and then I end up selling them on Etsy. Just because it's my way of kind of giving back to the community, because the community is actually a really, really tight-knit kind of thing. But yeah, that's pretty much what I'm doing. So today I'm modeling one of these. I'm trying to keep it in that same scale, so it's trying to be really, really small. And of course I have the real ones. I have real sirens too, not just little models. They're all stacked up over there, but I'm not going to show you my house. It's kind of a mess right now. But yeah, that's pretty much what the stream is, this going on in the stream. So if you like 3D modeling or you want to learn kind of how to do some of this stuff, it's stick around, or just kind of just enjoy. Let's see what else we got in chat. Kind of looks like an MS-290. I think it's because it probably was an MS-290. This was early on. That little picture was early on, like before, again, way before Vixen horns, way before like Lion King were kind of like known in the community. It was just like a siren you found on eBay. I think I got it for like $30 or something like that. I was like 12 maybe when I got it. Like I think I got it for Christmas, or no, my birthday. But yeah, it's probably an MS-290. But again, back then they didn't have any model names. They were just like, 12-volt siren horn that you'd see on eBay. AJ, he's modeling a miniature Federal Q. Yep. Bit Finesse, Federal Q siren, AJ? Yes, a Federal Q. Every American one. Yes, every American fire truck siren now, at least. You might be getting a Model 2 from a fire department. Congrats! That's cool. Is it a 240 or a 120? It's probably gonna be 240 if it's from a fire department. Bit Finesse, I must have subscribed to your channel on a dive into train horns and such. Very cool. I'm Bit Finesse. Cool if I lurk and soak up your streams? Yeah, of course. I'll be a siren enthusiast. That's badass. Yeah, thank you very much. Yeah, I've got. Again, if you're curious about some of the stuff I do, I have a couple streams below. Believe me, they're really rambly, just because I like to ramble a lot. So it's you might want to just skip through them, to be quite honest, to see kind of what I do. But yeah, and then I have also my regular siren videos that I post every now and then when I'm kind of like showing off a new model, or if I'm discussing something, or if I want to kind of just let people know that they're on the store. But yeah, I also do have a couple things of horns too. Not necessarily train horns, or locomotive horns, I should say. I do have a lot of the federal sign and signal electric horns. So I have like they're called resonating horns, but they're basically just electric horns that make basically the same sound as like a regular horn. They're really, really cool though. Not to be confused with fire alarm horns, which are very, very common. People they're like a horn strobe or something like that. They call them horns, but they're not what I would typically define as a horn, but that's just what they're called. But I have like an actual horn up top that's over there. It's a very interesting one. I'll probably show it later on in the stream. I'm a normie to you guys. No, it's all right. It's all right. It's no problem. I mean, like again, some people in the community can be really toxic, but I think people in communities in general can also be just like pretty toxic. But you're in good hands because I welcome everyone, so it's all right. Bro, I'm 13. You're good. Thanks, Abel. Abel's running interference. Abel's running defense for me here. AJ, we appreciate your interest. Yeah, of course. Like I said, to Bitfinesse, you're welcome here as long as you want to be. Sirens of New York, 120 volts. Sweet, sweet. That's awesome. That's interesting. You got a 120 volt Model 2. Sirens of fire alarms in northern Florida. Hey, who remembers when police cars had air-raid sirens? You mean like mechanical sirens? Yeah, that's seriously. I don't know where my little model B&M went. I have a, yeah, there it is. Oh, it just fell over. There's so much stuff on my desk. Yeah, there's my little model B&M, which I have to. This one is friction driven, so this used to actually just rub on the wheel of a police motorcycle. Fire alarm horns, awesome. Faraday 6020s, exactly, where they pretty much just vibrate. Yes, sir. I've gotten skilled at pulling incredibly useful things out of long-form ramblings. I think I'm going to enjoy myself here. Thank you all, of course. Yes, electromechanical, exactly. All right, so let's go ahead and let's stop. I'm gonna abandon the chat for just a couple seconds because I need to get back into kind of modeling some stuff, and you're probably getting bored just staring at Streamlabs. So let's go ahead and get out of Streamlabs, and we'll go do the actual model. So we're going ahead again. So we know now kind of where we're going at. So we have our bearing placeholder right here, which again is basically just there to soak up the space and leave me some kind of way of knowing where I'm at in the model based off of these two little bearings. So these two tiny little bearings are this little space right here. So this kind of should give you an idea of about how big this rotor is. It's not very big, which is why this whole thing is a real chonker, because I have to make it heavy so it keeps coasting. So now it's kind of an idea of how we're going to hollow out this clutch. Why am I bleeding? I'm going to stab myself on something. I'm bleeding now. Alright, so let's go ahead and start kind of continuing on with what we're doing. So we're going to try to hollow out this space a little bit more, because obviously this clutch is not going to fit. It's not going to fit in just this tiny little space. So we're going to make this a little bit bigger. I remember this is, well, how big is this? Like 18 millimeters around? 16 millimeters. Okay, so I've got 16 millimeters in there to play with. So let's give myself... I want to keep the walls relatively thick because the clutch is going to be pressing on those walls of the rotor. So, and I know that MSLA printed stuff is a little bit more fragile than PETG, which is the plastic I use for my FDM, my plastic 3D printed stuff, not my. Sorry, I was get the blood off my arm. But the resin is not nearly as impact durable as the PETG is. So I'm going to try to make these walls just a little bit thicker than I normally would. So I think 2 millimeters, actually even 2 millimeters is too thin. It's way too small. Let's make it a little bit bigger than that. Let's go, I don't know. Let's give it at least 3 millimeters. We'll give it at least an extra millimeter there. So let's go, we know that's about 16 millimeters there, so we'll just do 13. So we'll cut down to 13 there, go in here. We're going to cut out this ring. We're going to cut it basically almost right up to the bearings, I think. So we're going to cut it about that deep, because I want to make sure I have enough space in there. And I will have to put a spacer in between these bearings to keep the actual rotating section of the clutch off of the bearings, because I don't want it to rub against this. So, you know what? No, you know what? Let's go flush with the bearings. Let's go flush with the bearings. So this is This is all the space I have in here to try to model a clutch. You know what? Since we're here, let's get rid of the rotor. Let's also go ahead and just actually cut the hole for the bearings, just so I remember what size it was. I think these are like 13, or no, these are like 3 millimeters, I think, inner diameter for the bearing. Let me check my calipers again really quick and check this. I think they're 3 millimeters. Yeah, 2.93. So that's within tolerance. They're 3 millimeters. So we'll just say that this is 2.93. So 3. I want to make sure I'm staying within tolerance. I gotta make them a little bit bigger. No, I don't. No, this can be an exact tolerance, because this is going to be this is fake. This is pie in the sky woo-woo magic if everything was perfect, because everything is dimensionally modeled perfect in Fusion. It's only when you bring it into the real world that you realize the real world is out of tolerance all the time. So let's go ahead and cut those holes for this bearing. Let's just say that's the bearing right there. Go ahead and do an offset plane. Cut it halfway through. So they're 4 millimeters deep. So yeah, we'll do just so it looks more like 2 actual bearings and not just this little space. So let's say that about that. Go here, split this, splitting tool, this face. There we go. All right, and now I gotta make sure that goes away, because that's right where I don't want it. So make sure that plane goes away. All right, so now I have our 2 bearings. So we can kind of get a bit of a better visual as to where these things actually are sitting. So now this is the part that I'm going to be kind of interested in how I'm going to do it. So again, let me go and kind of describe what I'm talking about here. So let's do a Paul clutch and see if we can find one. Paul Clinton, that's fun. Or Paul George. No, I'm not looking at that. I guess Paul clutch. That's not who I'm looking for. Oh, I'm an idiot. I spelled Paul wrong. There we go. There's a Paul clutch. I spelled Paul like the dude Paul. Okay, this is what I'm talking about. So the kind of clutch we're going to be designing here is going to be a Paul clutch. So this is what this clutch actually looks like. So this is going to be the center of the hub. This is where our motor is going to attach to. And these little teeth that you see sticking out here, those are the pawls. So now in a perfect world, I'm trying to do this without using any materials that are going to rot. So there's going to be no rubber bands or anything like that. But because what I'm concerned about is that these pawls have to be able to close back in. They have to close back in around this ring to disengage the motor from the actual rotor, the part that's going to be coasting. We want to keep spinning. You don't want these pawls to stay out locked onto the rotor, because then the resistance of the motor I'm using, the resistance of the bearings in the motor and the brushes and the windings themselves are going to slow down that rotor really quickly. I want to make sure that these actually fully disengage. So my thought for doing them is that I'm going to be trying to see if I can print the actual pawl, the pawl itself, the pawl clutch assembly, I'm just going to say. I don't want to use rubber bands to close those pawls back in, because the centrifugal force of the thing spinning up super quick should be enough to throw the pawls out so they grab onto the rotor and get it spinning, but there's going to be no return spring, so there's going to be nothing there to pull the pawls back in once the motor is stopped to let the rotor keep spinning. So what I think I'm going to be doing is a bit of a compliant mechanism here. So since this is one of the beauties of using plastic, is that I can do stuff with compliance mechanisms. And if you're unfamiliar with what a compliance mechanism is, a compliance mechanism is dependent on the physical structure of the material you're making, or it's dependent on the physical characteristics of the material you're using. So in this case, compliant mechanisms used to, say this stuff, see if I can find a GIF of one, so you guys can kind of see what I'm talking about. So a compliant mechanism, let's see if this is one right here. You should be able to see that it allows this, just because of the way that it is actually formed, this little bit of plastic is allowed to basically act as a spring. In this case, over however many cycles, it eventually will end up snapping this because of the stresses induced on the plastic, because this plastic is not intended for this kind of purpose, but it just happens to work over a certain amount of cycle lives. But my idea is that we're not going to be physically and like roughly kind of shifting something over. All I want this thing to do is basically just once it spins up, the pawls are heavier than the strength of the compliant mechanism to allow the pawl to fly out and grab the rotor. Then once it stops, the pawl wants to sit at a certain position, so it will return just due to the natural property of the plastic itself. I want to experiment with that first and see if that works. And if it doesn't, then maybe I can find some way of making it work with like a small like little silicone rubber band or something like that to make the pawls actually return and get off the siren. Of course, this is all going to be for a prototype, so we want to see if I can make this work as a prototype first, and I will practice. I will use it. I will cycle the siren over and over and over and over again. I can probably even make an Arduino do that for me, just so that it does it over and over again, to see if I can find at some point where the cycle life of that little clutch just is too much and it ends up just getting stuck or the pawls break off. But we'll see about when that cycle time is. But I'm hoping that maybe it won't even have to do that. So we're going to go and kind of try to do that. So that's my idea for how we're going to make this clutch work, is using compliant mechanisms and using a pawl style clutch. Okay, so we're going to try to fit all of that in here. So let's see if we can do that. Now, I'm not going to bother trying to model the rest of the rotor. That's all pretty easy stuff. I've done that 1,000 times before. That's not the hard part here. The hard part is getting this clutch small enough to fit in this little tiny little space, and making it durable enough to last specifically for customers, people that are going to be purchasing this if they want to. Let's see what the chat's saying. What's your favorite siren in general? I don't know are you referring to me specifically, or I don't know who you're talking to specifically. Also, something neat. I recently stumbled across the only current known system of customized ESC 2030 Waylands at 515. Really? I'm not sure why they run that pitch though. Yeah, that's kind of an odd one. Sirens and fire alarms in Northern Florida. Do you own any fire alarms? If you do, can you make a video on them? Yeah, probably at some point. Tornado Sirens Robic. Hello. Hey, what's up, man? Wow, people are... I was up to 8 viewers. Everyone's leaving the chat now. Yeah, I got really rambly, as I was saying. Shout me out on my basketball skill. Yeah. For those who are wondering, Able Wrestler 1 is my younger brother. And he's a basketball player, man, playing in middle school. I'm hoping I can get to see one of his games when I go back to California. But yeah, this is basically a brief little look at that. So we kind of know what we're going to be working with. So let's see if we can kind of just do it. So I don't want to actually be constructing this inside this right now. So let's go ahead, and this is going to be in my way as I'm trying to model this. So let's go ahead and make an offset plane. Put a plane right there so I've got something else to build on. And then let's get rid of all of this noise here. So we can get rid of all of this stuff. So we have a nice clean slate to kind of build on. So I guess we'll start with the clutch. How we're going to do this. So these motors they rotate clockwise from the shaft end. So let's take that into consideration. So we're going to put our little circle here. Let me make sure this lines up with the rotor. It does, right? Make sure it's concentric. Yes, it does. Alright, so I don't have a lot of space. In here. Let me bring back the rotor. Yeah, let me do another section analysis really quick, actually. Go away, man. I don't want this. Go away, sketch. Thank you. Okay, let's do another quick little section analysis. I'm just going to finish this sketch, just so I can see kind of where I'm at. How much space I have? Yeah, let's do that. So I'll do another section analysis, just so I can kind of get an idea where I'm at. You might hear my cats kind of screwing around in the background. They're probably just going to do that in the video, so just be aware. All right. So we just went ahead and put a construction plane, so I've got something else to kind of build off of. So let's start with trying to make the actual clutch itself. So I want to make sure there's enough space for the for the actual pawls to kind of fly out and actually grab the clutch or grab the rotor. But I also don't want to make sure. I want to make sure that they're actually like in close enough that they don't continue to rub. So I think 11 millimeters. The inside of this is 13 millimeters. If I make the wall, the actual pawl itself, 2 millimeters deep. 10 millimeters. 10 millimeters seems a little small. It seems a little small. But we might be able to do that. That would give it, I think that would give it plenty of space for these pawls to kind of fly out. I don't know. Either 10 or 11. It really is just like a 1 millimeter difference, but it makes all the difference once you get later on down the road in the model. I'm gonna go with 10 millimeters. Man, that leaves quite a bit of open space inside there, but we'll deal with it. Okay, so 10 millimeters there. Let's go ahead and actually give this some volume here. Let me get rid of that section analysis because I don't want to be able to see through the whole thing, but I do want to be able to see through the other side, and we'll see about how deep we're gonna make this. It's gonna be kind of a deep clutch. Add our bearings back so I can see kind of where I'm at. I think that's pretty good. We'll get a little closer to the bearings. I'm going to put a little lip on the actual rod that's going to come out and actually hold onto these bearings. I'm going to put a little lip there to actually make sure the bearings, or the whole thing stays off of this whole face in there, so that the spindle of the clutch doesn't keep rubbing on the actual rotor itself. So there's about a half a millimeter there, so we'll leave that the way that is. And then we'll come back on inside, and I'm going to add the little pin that's going to hold on to those bearings. Now it went away, so I can't see it. There we go. And how big were those bearings? Those bearings, again, were 3 millimeter inside diameter. The clutch itself is probably going to have to be printed out of PETG. Those are Wheeling sirens in the background, in the cop cars. So this is going to be PETG printed. I think because I want to use PETG for this because PETG is more flexible than the resin is, and I know we'll be actually able to flex out there and make contact. So let's use PETG for this. And I have to remember that the PETG tolerance is a bit different. PETG tolerance, I think, for this kind of stuff is usually about 1.5 millimeters over whatever size is measured. MSLA is 0.5. So it'll have to be, like, say if this is 3 millimeters, and I have to go 1.5 millimeters in from that. So 2.85. So make the shaft 2.85, which should be the perfect tolerance to fit. Oh, you know what? Hold on, I have to do this first. I have to make that little lip I was just talking about. So we'll come back in, go off of this, sketch that circle again. So we'll make it just a little bit larger, just so it keeps it off. So 3 millimeters, let's make it 4. So 4 millimeters there. Come up off of that half a mil, because we know that's the size we're using. So half a mil, which will get us right up against that, which I know looks bad, but trust me, it'll work. So half a millimeter. We do not want to join those together. Make sure you pay attention to that kind of stuff, because Fusion will go ahead and end up welding stuff together if you're not paying attention, and it'll end up screwing you later on. So we'll make that size, make us have a little bit of a lip, then make this center section again. Get my analysis back. We're going to make that 2.85. That's 2.86, you moron. Go back. There we go. Alright. So now we can go here, pull that sketch out, get rid of our section analysis, get that section analysis back. And this is going to be the pin that's going to slide onto those bearings to actually hold it on. And I don't want it to go all the way to the end, because if it goes all the way to the end, it's going to hit the front cap of the stator. or the rotor. I might also even add, since where this bearing is placed, I might actually add a little hole on one of these sides just so you can actually get in there and actually oil the bearing if you ever have to for whatever reason. But we'll just join that together now. So now we have essentially the root of the clutch. Alright, so now this is going to be kind of the hard part, which is how the hell am I going to make this? How am I going to make this? Let's get rid of these bearings. I'll get rid of the bearing placeholders. And I do not need the section analysis now on that, so we get rid of that. So here's the drum. This is it's basically is going to hold all of. Why is my STL10 still here? Get rid of that. We're going to make this drum. So let's see how are we going to do this. Because this motor spins pretty fast. These are the motors I use. They're RM130 motors. If you want to look up like what size they are, they're little RM130s. And at 5 volts, they spin at like 9,000 RPM or something like that, something insane. Or is it either 9,000? Yeah, I think it's 9,000 RPM. They're quick little bastards. But we'll go from there. So the center hub of this, since I know the motor shaft on this is 2.1, it's like I just know it's a 2mm shaft, so 2.15. Don't ask me how I remember that. I just do. That's just the tolerance I know I have to work with when I'm making MSLA stuff, or no, FDM stuff. I'm going to add that back so I can see kind of how deep I make this hole, and then I got to measure how deep the motor shaft is. And the motor shaft is, wow, there's a lot going on Main Street right now. Motor shaft is about 7mm. 7mm, yeah, about 7mm. So we're not going to go 7mm, we're going to go 6. That is the wrong direction. There we go. Okay, so 6mm, so that'll bring us off of this back little lip of the motor by 1mm. This little back lip, so you see the motor right here. There's the actual shaft of the motor right there. There's this little lip that actually that's the front bearing of the motor itself. We're going to come off that because we have to make sure that this is not going to touch that. Am I still bleeding? Man, I don't know what I did to myself. I must have caught myself on something. So make that 6mm. This whole thing is going to be kind of really just dangling off of the front of this motor, so I'm going to have to be very, very careful to make sure this is centered correctly. I might even have to make this MSLA printed just in order for it to work properly. Which I don't want to do, but I just might have to. Okay, so now it's going to be trying to figure out how we're going to cut these pawls. So they did theirs with like a round thing. I can't do that. I have to make them pretty thin. What's that one? Oh, that's a cool one too. That's pretty much what my idea is for making this mechanism, so it allows it to return. So we're kind of going to be going off of some almost like that kind of idea. That's imparting. This kind of mechanism is imparting a lot of torsional load right there. So that would be the failure point, is right there at that joint. But we're not going to do that. We're going to do something similar to that. There's the compliant elephant. I've seen that before. Oh, you know what? Yeah. Alright, so this is going to be kind of just a freehand thing. So let's see what I can do. Let's start out with doing some fit point splines. Let's do some splines here. Actually, I want to set up some kind of barrier here. So let's go from that center point down to the bottom edge, just so I kind of have some kind of compass rose lines here, so I can have some like very accurate places. I have to make sure this thing is balanced. It's going to be spinning so freaking fast. So let's make sure we've got some kind of points here to work with. Let's say about right there. That's fine. Now is the hard part, is how am I going to make these just barely come off that edge and not just like destroy themselves. I guess I can probably really just do it on one edge and then work my way in, or then use the pattern tool. So I only have to do it once. So I have to make this section down here kind of thin. Apologize, guys. Give me kind of a second here to figure out how I'm gonna do this, because this is, I've got a lot of space. I got a gap too. There's a lot of space I gotta worry about. Yeah, that's a lot of space to deal with. Because there's the actual rotor itself right there. I can add the poles to the rotor, no problem. That's not the hard part. The hard part's just making this clutch kind of work. Now I want to make this, the inside of this, reasonably thin, but I want these to be like long enough that they're gonna want to fly out when the motor gets spinning really fast. So I'm gonna say, let's try to make this structure right here off of this one line. We'll go, I don't know, like half a mil in. Yeah, about half a millimeter in. So that gives us a point we can actually base off of right there. And then we'll go up from there just a little bit, just to give it something to kind of work off of. This is going to be a lot of the fine tuning kind of junk here. Now I have to make sure that this is going to be heavy enough to fly out. So we'll kind of do a 5-point spline. Yeah, it's going to work perfect if I do that. Will that work? That might work. Shoot, man, even that size itself might work fine. And it's nice to keep them round. Whoa, what are you doing, man? Okay, and it's nice to keep this kind of still round because it allows, or to keep this edge of the actual pawl that's going to fly out round, because that means that if it doesn't actually return all the way once the motor is done spinning, if the actual teeth that are on the rotor actually end up hitting it, it'll just be directing it backwards, back into the actual clutch itself. So it'll kind of help protect it that way. So we're going to keep that edge. Where is it matching up at? It matches up right there, but it doesn't think this is closed, doesn't it? Oh, it does think it's closed. Okay. Then why was it giving me such a headache that it was fighting me? Like it didn't want to keep it. Okay, that's fine. And I do want to keep the actual rotating mass of the clutch itself kind of low, because I want it to slow down like that once I cut power to it, so that it lets go. So I don't want this to keep spinning and keeping those pawls out, because then it'll stay engaged. So I want to make sure that this doesn't kind of stay like that. So let's go ahead and add another fit point spline. We'll add another fit point spline. We'll add this spline just a little bit lower. Basically just going to cut this section out. Just give me a little bit of a gap here. Let's just do right there. Yeah, and then it'll bend away from that as I move. Sweet. How big did I make that? I made that like a 1 millimeter square, or a half mil. So, go from there, we'll go right there. Yeah. Yeah, and then we'll go in here and draw a line and connect that to there, so that I can cut this little section out now, and that'll give me one of the little pawls. So if I go here, go in, press pull, I can now cut that section out. So I basically have the edge of the pawl now. The problem is that gap might not be big enough. So when this printer prints, again, you have to worry about the tolerance of the printer, and this is going to be printed using the MSLA printer, or not the MSLA, the FDM printer. So this is going to be the hot molten plastic, and when it's laid down as the first layer on the bed, it tends to flow out. It creates what's called an elephant foot. It's what's just known in the 3D printing industry. But so that elephant's foot is going to end up closing up that little tolerance I just created, unless I make sure that this is actually wide enough to compensate for that elephant's foot, to make sure it's not going to scrape on anything. So we're going to have to, or it's not going to basically weld the whole entire thing shut. So I might have to make that a little bit bigger. I want to pull it out first and just see what it looks like. And I think that even even that's probably still too thick. Let's see how thick this is exactly from edge to edge. half a millimeter. I mean, doesn't seem that thick, but even like looking at it, it looks really thick. Let's do half a millimeter, see how big that is. That might work. That might work, actually. That might work. That's pretty thin, but it might work. Alright, and I'm going to have to cut a little relief edge here. About like this, just to make sure that this is actually going to have enough room to kind of have a point to flex on. So that is really, really small, but we'll see if that's going to work. How far is this edge from itself? Ooh, that is really tiny. Ooh, that is, yeah, that's really tiny. That's probably going to be way too small. It's 0.7. Wow, that is so small I can't even see it in the calipers. That's okay. That's way too small. So we can't do that. That's not big enough of a relief edge or a open space. So we're gonna have to make that a little bit bigger than that. That's no problem. I just showed you how I did it. So I was gonna go back in here to find fit point spline again. It would probably help if I actually gave myself some lines to work with. So we can do about half a mil again. Do 0.5, so make half a mil of a gap. And my printer should be able to print that, so that should be no problem. So half a mil there. Where's my little guideline I just made? There's the square. No, wait, no. That was not the square I was on. There you are. Okay, so we're going to do that. Come down. How big is that? That's about 1, 2, 3, 4, 5 squares. 3, 4, 5. Right there. That doesn't look right. That doesn't look right at all. Maybe it is. Maybe, I mean, in other words, it doesn't have to be perfect. So we'll just say it's that. Whatever. That will at least give us some kind of space on here. Yeah, that'll give us some space. Let's say right there. Why not? Okay, so now can I cut this out? Sweet. Okay, I can now. I do have to make that relief edge again. So I have to continue on with that. I wasn't done. Because I just, when I backed up to fix what I just messed up, I ended up creating a kind of another problem. So we'll make this go down about another half a mil, just to give us a bit more space for this whole thing to kind of flex on. And that pawl is pretty sharp on the other edge, which is perfect, so we want. I might have to make that even longer. I have to make sure this is going to be flexible enough to actually open. Because if this plastic is too strong, then it doesn't matter how fast I get the motor spinning, because it's not going to be strong enough to... This centrifugal force is not going to be strong enough to make this whole section right here actually fly out and actually reach the edge. So I might have to make this a pretty long relief angle, or little relief area here. What are you doing? What? There we go. So let's make that pretty generously long enough so that this should work. God, I hope that does. That's going to be a lot hinging on that one little spot down there, but that should be pretty good. So now we'll go. Where did you go away? Where'd you go away? There you go. Now I'm at the point where I'm just kind of talking to myself, so bear with me for just a sec. Make sure that goes away, and then now I should be able to go along and actually cut that entire edge out. If I cut just like that. Why are you still connected at the top? I didn't want you to do that. Now I'm just kind of making myself angry. I want you to be open at the top. Why were you not open? I'll just make a little, this will be pretty quick. I'll just make basically just a little thing just so it's open right there. Make it go over whoa, not 5 millimeters. Not 5, 1.5. No. Okay, let's make sure we do that again. 0.5. 0.5. Thank you. Okay. Go back to that edge. Alright, so now when I press this out, I'll make sure I actually press that out too so it won't be joined. Man, what is going on Main Street right now? There we go. Should be able to cut that whole thing out, and now we'll have the space. So we'll cut that. That looks pretty good, but it would be unbalanced at this point. So this is where we have to go in, and we will do my favorite thing, because it feels like a cheat, to be honest, is to go in here, go to our section analysis, and I should be able to highlight that whole entire thing, kind of, and then just select an axis, and then it will basically, whoa, we're not adding 10, we're not adding 9, we're doing maybe 4, if I can get lucky. I don't think I am. I think even 3 would kind of be pushing it. Let's see what it looks like with 3. That could work. That could work. That might work, actually. That keeps it really light. There's not a lot of mass in here, which is good. So it keeps that whole thing pretty light. I could honestly even come in here and actually cut some holes and make this even lighter than that. Because again, we want this whole clutch section to be as light as possible. Because we don't want it to, again, stay engaged. So I can see if I can go in here and cut just a little hole. Yeah, sweet. I mean, it's like 1 millimeter, but I mean, it's weight reduction. So we'll cut one little hole. Let's see how that works. Along that edge. Cut that. Now, am I going to like that, or is that going to end up biting me later on when I find out that this is too out of my tolerance? And do the circular pattern again, come back in here, select that hole, go into axis, just select, I'm not doing 8 of them, or 10 of them. Let's do 3, like it was before. So 3 of those. There we go. And there is the center of our clutch with the included weight reduction holes. Try to keep the weight down again. That looks pretty good. I'm not too fond of compliant mechanisms in 3D prints because they typically don't work very well. Again, because of cycle life, they don't like to be cycled very frequently, and I'm kind of concerned that this is a really close gap right here. That's really close. I don't think the printer can even model that. Yeah, how far is that? 0.2. I don't think it can even model that. But you know what we can do? Because the magic of having a 3D printer and having the software to do it, I can come in here and we'll check really quick and see if this is even going to match up. So I'm going to select this, I'm going to select 3D print so I actually can see what it does. Why isn't this connected? Why aren't you connected? This, for some reason, the actual support for the bearing wasn't actually tied into the... There we go. That was dumb. Alright, so now I can take the whole thing. Let's go ahead and export this. Let's just do... this is another thing I'm working on right now. Let's do clutch. I'll find it again later, but let's go out here. There's a compliant mechanism. And there's Streamlabs. Wow, I've been doing this for an hour already. Alright, so let's see if I can, we're going to read some of the chat really quick. There's a lot kind of going on. My throat is so screwed up right now. Okay, back where we were. Favorite sign in journal, I already answered that. Do we own any fire alarms? Yes, I do. I think I talked about that just briefly just a second ago. But I do own a fire alarm. I have one. I'm not really super big into fire alarms, I will admit. So I really don't have a lot of them. But I do have I think it's a first alert, actually. Not a first alert, a P2R. So I have a P2R strobe with a candela selector in the back and stuff like that. I mean, I'll probably do a video on it later, but again, I'm not a big fire alarm fan. There's people know way more than I do, so I try to stay out of that. I stick with what I know, and that's sirens. But yeah, I've got a P2R. It still works. I mean, I found it on top of a roof when I was working. But a P2R, and I haven't done a video on this. I'm hoping to do one at some point, but I do have a Selectone, which I don't think anyone's actually seen. It's a Selectone 314. Selectone 314 GCX. So that's that right there. Very, very loud. This thing, I swear to God, you can hear it like across the city. It's got like it's only a 15 watt driver, but it is extremely loud. And this has a UTM in it, so a universal tone module, so I can do every kind of tone I want. This is my cat on the scratch post. But that's another fire siren, I guess you can consider it, or fire alarm. And then one of the other people that I have just recently met in my chat that I haven't talked to before, I was referring to horns. What was your name? I forgot what your name was. I'm so sorry. Bitfinesse. This is the horn. This is the horn I was talking about, the electromechanical horn. So this is made by Federal. This is a 53, I believe, actually. It's probably 52. No, 56, actually. Stand corrected. But there's a 56, Model 56 horn. This is actually brand new. This is new old stock. I got this for a really good deal. I got this actually for my birthday last year. But it even still has the original tag on it. So there's the original tag for when it was basically purchased, and then it was never installed. So it's never been hooked up. I haven't even hooked it up myself because it's 125 volts DC. And I really don't want to just take a cord, hook a rectifier up to it, and then shoot it into this, because the RMS voltage of the household voltage would be like about like 200 something volts. So it would end up killing this. I don't want to do that. And also, it just being on just rectified DC with no smoothing capacitor, it would sound like dog. So I don't want to do that. But yeah, that's the horn I was talking about. It's one of my favorites. I love these resonating horns, but I really wanted to get this one, not only because it was never ever installed, but also it is very, very rare to find one that's got that style horn shape on it. So it's the low profile version of those horns, but super cool. So yeah, but yeah, that's basically a bunch of some of my stuff I really haven't done any videos on, just because again it's just not stuff I typically talk about. It's just pretty much just for my own. Ooh, let's give you a foot shot. I'm sorry. I didn't mean to do that. That's pretty much. I just haven't done videos on them just because they're not like I really don't know how I could do a really long format video on them. Just I don't know. I don't think people would be super interested in them. So stick around to sirens pretty much. But yeah. Okay, something neat. Okay, let's talk about the Wayland sirens. I remember that. Do you own any fire alarms? Yes, I do. I showed you that. That's what I was responding to. Basketball. Sirens and fire alarms in Northern Florida. You play basketball too. Cool. Remember when we went into those water tanks? Yeah, the ones at Griffith Park. The ones that are gone now. Yeah, I remember that. I wish those Waylands could just break their wires. Oh, you mean like spin all the way around, just like strangle themselves? AJ, why? There also there is no rotational mechanism on vehicular sirens. Well, yeah, there's not. Well, unless you're referring to like the pulsator sirens that were in New York, but those weren't rotation. Those weren't rotators. Those were just dampers. RM130 siren. Oh, you're referring to I think you're talking about the motors. Yeah, these are RM130 motors. I might make an RM130 at some point, but it's just got more other interesting stuff to work on. Bitfinesse, 9,000 RPM. Holy smokes! What kind of lubrication that require? What keeps that thing happy? Sewing machine oil, which I know is a very, very odd thing, but yeah, sewing machine oil is perfect for these tiny, tiny little motors, because they're just you need a really precise lubricant, but you also don't want a really thick one because it'll gum the bearings up. Um, Tyler Davis. No way. Tyler Davis is in my chat. Tyler Davis in my chat. Maybe use a soft rubber sleeve that's adhered to the shaft, so when you turn on the centrifugal force makes it grow and lock on the drum. That was kind of what I was thinking, because I've seen those before. I was considering doing something like that out of like, I don't know, like Ninja Flex, or like a soft filament, like a rubber or soft durometer filament, but I don't have any of that, and I can't justify buying like a whole spool for just like a tiny little component. But yeah, I thought about that too, because I know that looking at the, if you just take your toys apart like I used to, you probably recognize that kind of clutch design. They used them a lot in really cheap like servos for like RC trucks and stuff like that, where basically it's just like a little drum and it just flicked the wheels back and forth. That's pretty much what they used. Hi Tyler. Yeah, I'm with you, AJ. I was surprised to see Tyler in here. Tyler, the best mini siren maker. Hell yeah, man. I love all of his stuff. You have a lot more skill than I do when it comes to making your sirens, dude. I love seeing you machine them yourself. That's freaking awesome. They're tiny little hobby motors with little brushes that eventually wear out. They are cheap and aren't meant for continuous use, but work fine for small sirens. Yeah, exactly. I'm like, they're not really I mean, and like from what I've found, because these same kind of motors are used for like model trains. At least a lot of them are used for model trains. They really take a long time to wear out. Like, I really haven't found any of these that have actually like realistically failed. And like, I don't think. And everyone always talks about like having to replace brushes, and I'm like, I don't really think any of these motors are like, I'm not running that much power through them that you realistically would ever actually end up replacing brushes. I mean, in this kind of form factor, you really can't. You just throw the whole thing away, which immediately sucks. Sirens of New York have a brushless. I have brushless ones. Yeah, they make little brushless motors too, but they're just too small for that. I feel bad for that elephant's foot. Able Wrestler, can someone give me a... Oh, whoa, I zoomed right past. Can someone give me a brief summary of how this works? I just explained it, man. Roblox Guy Fan 1000, make a STH10. I probably will eventually. I've made the STL10. The STH10 is soon to follow, so. Bitfinet sounds like Pego pieces. Mr. AJ planned obsolescence paying off here. Pego pieces. Pego pieces. I don't know. Do you mean Lego? I'm sorry. I'm not trying to sound like a dunce. Yep. Bitfinesse. Whoa, a siren is basically a super high RPM sound pump. I've never thought of sirens like this. I've only ever heard the word spline used in reference to impeller pumps. My mind is like on the walls. Sirens and fire alarms in Florida. A siren is basically a high-powered fan. Yeah, exactly. There we go. Sirens and fire alarms in Florida. I couldn't have said it better myself. Oh, cool. An L series strobe. Is that what they are? Yeah, exactly. Again, I don't. When it comes to fire alarms, I have no idea. Like, honestly, I don't know. I don't really know all that stuff. I basically know like the older like Gamewell and like Waylock stuff, and that's basically about it. Or Wheelock, excuse me. Sirens and fire alarms of Northern Florida. Yeah, I understand. I like sirens, but I also like fire alarms. Yeah, I get it. Don't make fun, but who's Tyler? Oh yeah, Tyler is go look on his channel, Abel. He's another siren maker just like I am, but he does like crazy stuff with like, he's made like, the mini Thunderbolt that I have that's in Grandma's back room. He made a larger version of that that was like actually made out of metal, which is very, very awesome. I would love to see it someday, but yeah, if you go look up Tyler Davis on YouTube, you'll find him. That is interesting username. Is it 60i70L or boy71? I don't know exactly what it's supposed to say. I have a 3D model I made in Blender that I want to print. If I shade the model smooth in Blender, will it be printed smooth or flat? If you shade it, it should come out smooth. I mean, usually, I've found that the printers if you, depending on what slicing program you're using, the printers oftentimes have a kind of a hard time trying to slice things that are just taken off of like actual like just regular 3D models with that don't have some kind of way of actually turning the file into an STL. They have weird, you get weird artifacts where it ends up making the whole thing like really like polygonal, where it has a lot of like really weird shapes. I'll show you really quickly. Like there was a model over here somewhere of a little fat clown. It was a long inside joke of my friends, but there's a little fat clown. His name is Biggles. Where's Biggles? Where is he? Where's Biggles? Biggles is hiding somewhere. But he was modeled. There he is. But Biggles was modeled using SketchUp, and SketchUp just does not like to try to make that kind of stuff. There's a fat little clown. And you can see it adds a lot of polygons. So, I mean, like, I don't know how Blender works really that well. I haven't used Blender in so long. And I never actually tried 3D printing anything with it. So, I don't know. You can try it, but yeah, there's Biggles. It's, again, a weird tangent. But again, let's so my whole thing I want to see if this printer is even going to be able to model this little tiny gap in between here, because it's really, really tight. And I'm kind of afraid that it won't be able to do it. The Ray 2009, what's your favorite siren? What's your favorite siren in general? In general. Well, considering I have a total, I have a total of, well, now I have a total of four Model Ds. One of the videos, I haven't posted the video yet, but I got two really, really badly beaten down Model Ds from eBay. The people that are in the chat they probably even saw it on eBay a while ago. But I took them up like a while ago now. But I have two very, very, very old Federal Electric Model Ds, and I love the Federal Electric Model Ds because they're the ones that have the larger motor in them, the Dimpleback Model Ds. So now I have three Federal Electric Model Ds, and then I have one Federal Science Signal Model D from like the 50s. But yeah, I think Model Ds are probably still my favorite because they're really, really up there for me. So yeah, I'd say probably the Model Ds. Probably the Model Ds, because I have the most of them. So I've got four Model Ds, two Model As of both generation, and then I have the CS8M7, the C5, and then I have the ED Bollard, the little 6-volt ED Bollard. But yeah, so let's go ahead and see if this is even going to be able to slice. So let's go ahead and go to Prusa Slicer, which is my slicing program. Open this up really quick, and then we'll see if this is even going to show up properly in the program, because I'm kind of skeptical that it will. Where is it? Immediately, yeah, I think I hit it in here somewhere. There it is. Whoa! Whoa! That thing is tiny. That thing is... Wow, that's a lot smaller than I thought it was going to be. I don't think it'll even be able to do that. Let's try. Let's see if it can even print that. Yeah, that's what I was afraid of. Yeah, that's what I was afraid of. It can't even model it because it's just too thin. Okay, well that sucks. Well, let's see if... Man, I might have to model it with the MSLA printer. I really didn't want to, but I might have to. I might not have a choice on this one. Let's see if it can even model on the other one. It should be able to. Let's see if it works for the MSLA printer. I hope this doesn't spoil it, because usually it opens up stuff I was already working on. Okay, good. It didn't spoil what I've been working on up here. Let's see if I can put that in there and see what this looks like when I slice it. Wow, it actually placed it on the build plate correctly too. Slice that really quick. And was it able to do it? It might have. Holy crap, that is really small. God, man, that is tiny. Wow, there's a lot of artifacts too. I might not be able to do it with 2. I might have to do it. I might not be able to do it with 3 wings. I might have to do it with just 2 because that eats up a lot of space. Yeah, that eats up a lot of space. I might not be able to do that. That's gonna be. It's a long print too. 44 minutes. I think it was like only a couple minutes with the Prusa. If it even tried. Yeah, 30 minutes. Oh, well, I guess that's long too, actually. Okay, so we're gonna have to go back and kind of change a couple of things. There's the compliant mechanism again. So we can't do 2. I mean, we can't do 3. We have to do 2. So let's get rid of those holes, make those go away. Disappear my mistakes. Okay, we'll go with this. Let's go back and let's see what 2 looks like. The only other reason why I don't want to do just 2 is because if one of these engages and the other one doesn't, then it will lead the whole thing to be out of balance when it's spinning. Especially if it's going to be spinning at like 9,000 RPM. I want it to be pretty balanced. Let's see. Let's see if that works. Let's see how that... No, that looks alright. Let's sketch another hole. We'll cut out some more space. Man, that was really a treat having Tyler come into the chat. I appreciate that, Tyler. Okay. Go ahead and make that. No. Make that model over here. Pattern. Circular pattern. I'm just going to put that on the other side. Just 2. Yeah. There you go. Okay, let's try that. Let's try that instead and see if that's a bit thicker, and it should be able to do that, no problem. If not, if it can't, if this edge right here is still too small, I might have to just change this relief angle a bit more, just so it gives it a bit more space to kind of work with, because I don't want it to snap right there. So again, I want my sirens to last. So if it's, I'm gonna of course test them out and make a prototype first, but I want to make sure it's all gonna be working properly before I actually get them out, because I don't want them to have to work for like a couple days and then end up like snapping the clutch or something like that. So yes, replace that. Okay, go here. Let's see if I can put it in there now. Okay, put the clutch back in there. Slice. Probably still can't get it. Yeah, the Prusa still can't quite get it, even at the super high detail. That's just too much. That's just too much. But I know it's not going to work. It's not going to work with the MSLA printer. It's just not flexible enough. This is a pretty rigid filament. Or a pretty rigid resin, I should say. So this is not going to work. So I have to make this... What can I do to make this work? What can I do to make this work? Okay, I need to get off of that. This thing is wigging me out, seeing this thing just like sitting there gyrating. Let's get away from that. Alright. Go back to Fusion. Alright, so this is going to have to be just a little bit thicker than that. Let's go back to when I was actually sketching that. Make the rotor go away. Oh, there's the sketch. It was on the back side. Okay, so let's not press pull that whole thing out this time. Let's actually just give us a bit more. Let's give us a bit more space, just to make this hopefully stay closed. Okay, that should be good enough. Do that. Get a circular pattern, make this a circular pattern. Do this one as axis, make 2 of them, not 3. Because I think 3 still cuts over a little bit too much. Actually, it might not anymore. No, I'm just going to go 2. I don't want to deal with it not cutting right. Alright, so now let's see what that looks like. Update that. Yes, update it. Ooh. No, it wants just this one. Oh, you stupid... I hate that it does that. I don't know why Q2 likes to just impose itself on me, and it thinks that it's a Q2. It tries to open it with Q2 every single time. Okay, let's slice that. No, they're still not making contact. This little gap right here. I need these two to be touching each other. Man. Let me think. What if I move it further back in? You guys are now currently learning with me. You guys are seeing the kind of the process of how it goes into making these sirens. There's a lot of tinkering in order to kind of make them work right. I think what I'm going to do is I'm going to move this edge a little bit. I'm going to move it a little bit further away from the edge of the actual circle itself so we can just make this work right. Yeah, sure, on that. Whatever. Let's do this. Let me get rid of this so I actually can see what I'm doing. There we go. Okay. Yeah, let's move this over a bit. Let's see if I can... No, come on. Line up with this, please. Thank you. Yeah, let's see if we can do that. Let me add that back now so I can see. I know these lines are probably really, really hard to see, and I apologize. Actually, realistically, you could probably just cut just that. Yeah, let's try just that. And just not even give it a relief at all. Yeah, let's try that. Okay. Whoa, there's only one of them. I gotta make sure there's two. Okay. 2. There we go. Do the same thing again. Update that. Yes, it exists. I'm just going to update it. Clear out this garbage. Okay, and slice. You still don't want to... Oh, there you go. There we go. Now it's connected. There we go. This is why it's important to check that it's actually going to work before you try it. So that's cool. So that lines up. It looks like crap, frankly, because it's so small. But that's kind of just... Why are you hollow? I don't want you to be hollow. I want you to be solid. Okay, make you solid. It's honestly so small that I doubt I'm really going to have any issues with it spinning down too slow. So I'm really not that concerned about it. Now that I see it realistically how small it is on the print bed, because it is really small. So I think we'll probably be fine. Yeah, how long are you going to take to print that? 27 minutes? That's not even that big of a print. Okay, let's go with that and say that that's going to be kind of our base here. And I need to combine this again really quick. Combine that and that. There we go. So then that's one part, thankfully. So I'm gonna stick with that. I'm gonna call that good, just like that. Of course, I'll print it twice. So I'll print it in PETG, and then we'll go ahead and we'll also print it in MSLA, and we'll see just which one works better. I think right now I have this sized for, yeah, I have it sized for FDM. So that's sized for FDM. This rod right here should be sized for FDM as well. It should grip those bearings tight enough so that the rotor doesn't slip off of that motor shaft. So this should be pretty good. Okay, now our rotor's right there. Okay, this is a really, really, really small clutch. I'm hoping that it's not going to have a whole bunch of force put on it, but alright, so the direction of the clutch is going to be spinning counterclockwise from this direction, but if you're facing it from the front, the clutch is going to be spinning clockwise. So I'm going to have to make sure I put the vane, or I design the vanes to be facing the right direction. So let's get rid of the actual okay, we'll call this the clutch pawls. Okay. And then we'll just get rid of it right now because we don't need it. And is the sketch still there? It left the sketch. What are you doing? Why'd you leave the sketch? Why'd you leave the sketch? Get rid of the sketch. There we go. Okay. So, I know we're just looking at a blue circle now. So, where am I? Okay, there we go. So, now I have to make the actual teeth that are going to be sticking out, that are going to be actually grabbed by that center section when they fly out. So now it's kind of a little bit of a dance trying to model these. So let's go and do a construction plane, tangent plane. Okay, so we're going to be modeling it right here. This is where it's going to get to be a pain. So we're going to model, start sketching right here. Let's just start off with some lines. Oh, that's really annoying. That is really annoying. Let me do a section analysis again, because that is going to be a real drag if I can't see what I'm doing. There we go. Okay, so let's start making some pawls here. So, sketch, line. And I know that that goes down pretty deep. So we're going to go probably about right there. How far does this whole thing actually go in? Yeah, like I said, it's pretty deep. It's pretty deep. So try to, this little, oh, you can't see what I'm pointing at. And of course I can't point with the cursor because it'll move if I move the cursor. But there's a, if you notice when I line this line up, there's actually two little dashes. They're kind of right at the end of where it says specify next point. There's those two little dashes that are actually on the line I'm drawing. That just lets you know that that line is parallel. So if I move it off and it's no longer parallel, it just basically lets me know I'm parallel with this edge. So we'll go from there. Is that right on that edge? Yes, it is. Cool. I should be able to open two section analysis at the same time. But it doesn't want to allow me to do that, which is annoying. Why won't you let me open both? I want it because I would love to open both, so I can just chop this whole thing up and kind of see what I'm doing. But it doesn't want me. Doesn't want to let me do it. So that's annoying. That's a feature you should enable, Fusion. Okay, so I want to keep this at 90 degrees. You get about 3 millimeters wide, and then go all the way back up to the front. Okay, just like that. And then close it off. So now I should be able to pull this. Should be able to pull this inside. Let me add that clutch section again so I can see where it's at. Ooh, too close, too close, too close. Like that. Are we even centered anymore? That looks off-center. That looks really off-center. It is off-center. Come on, man. That should still be enough to get grabbed by this clutch. So, I don't want to cut. I want to join. Actually, you know what? New body, actually. Let's make it a new body so I can move it. Yeah, let's make it a new body so I can take this and scoot it where it's supposed to be, like that. Silly little thing Fusion can be. Fusion can be really, really stupid sometimes. But that's pretty much what I wanted to do with it. And then I want to get rid of this angle right here, this edge. I want to kind of shave that down a little bit. Okay, cool. Oh, it remembers. Distance and angle. I want to shave that down a little bit so that if, for whatever reason, if the actual pawl that's on the clutch for some reason gets stuck out, as the rotor continues to kind of freewheel and come around, it'll actually just ride up on that ramp and get knocked back in the center again. So we got one right there, and then now I should be able to just combine this with the rotor and not the pawl, and I should be able to combine it just like that. So now it's all one part, and now I can come back in, do a circular pattern again. Yeah, circular pattern again, features, and around this axis. And it really wants to put in 3 every single time. I don't know why. But we might as well do a little bit extra duty here and just do 4. Might as well just do 4. And it didn't model that edge. Why didn't you model that edge? And wires did not lined up? No. Okay, let's do faces then instead. That's stupid. I hate when it does it. Fusion can be a real hassle sometimes, I will admit. Because sometimes it just really doesn't want to listen to you. So let's just do faces, because it usually pretty much always gets faces. Yeah, 4 selected, and it's not selecting the back one because it shouldn't have to. There's nothing there. Right? Oh, you little... Okay, no, wait, what? Okay, yeah, it's inside that portion. Okay. That should be good now. So I've selected that around this axis. Let's do 4. Will it do all 4 of them, or will it actually keep that edge? Okay, cool. Fusion, you're so stupid sometimes. Okay, I don't know why it doesn't want to capture this. I just want to clone you, please. Actually, can I undo it being a body? It is, okay, so it's still a body in here. So it's still its own individual thing. In this save. So let's move the body over like that. So we'll keep it its own individual body for right now until I make a clone of it. Then go back here, do what I just did again, because Fusion wanted to be difficult. And now you don't want to play nice. There we go. Does that work? Does that work? That works. Yeah, that works. Okay, that works. Okay. Now do pattern, and now since it's its own individual thing, it should be able to find it no problem. Bodies. Axis. This axis. 4 of them, please. Now, do I want to do 4, or should I just do... Do I want to do 4, or should I just do 2? I might want to do just 2, because I want to make sure that these pawls have enough space to actually kind of open up, and then ride along this outer edge, and then hit the wall of the pawl to get spinning. Or no, the stub. Whatever. Okay, that's a pretty tight tolerance, but I think that'll work. Okay, now I gotta combine these. Okay, so all 3 of those are combined. And there we go. And that functionally... That should functionally be the clutch. That should work. Yeah, so that's the clutch, pretty much, I think. I think that's pretty good. I mean, of course, time will tell if it actually works. Of course, I'm gonna have to be doing some prototyping and seeing if it's gonna work. One of the things I don't like about this, and I might just have to, I might just have to scale the Siren up just because of just how small it is. It's probably just way too small to be trying to do this thing at this scale. But one of the things that's concerning me from an engineering standpoint is that all of the weight of this entire rotor is being held by this little pin. And this little pin is plastic, mind you. So if this thing gets dropped or bounced or whatever, it could very easily shear this plastic right off right there because there's layer lines there. So there's an inherent weakness with how it's constructed. And it could shear that little plastic pin off, and then the whole rotor would basically just be loose on this and wouldn't be actually held off of the clutch itself. Another engineering concern is that this little edge right here that's actually holding on this whole entire pawl, this weight, I'm concerned that over however many number of cycles that will end up snapping, and then it would render that siren useless, or wouldn't work properly because it would just be freewheeling all the time. So that's a concern of mine too. And generally, I'm just concerned about all that weight being transferred on that when this thing starts. This thing is going to have a very, very high point of inertia, initial point of inertia, because of how heavy it is, because of how heavy I've purposely made this rotor, so that once this motor gets spinning and these pawls finally open up enough to actually engage with the teeth on the rotor, I don't want it to just be spinning and all of a sudden slam into the rotor and then risk snapping this right here. It's another thing I'm concerned about. So there's a lot of things to consider on this. I'm not entirely sure how it's going to work. I guess this is part of prototyping, so we'll see if it works. If it doesn't, I can always engineer something else and then pretty much do something else. But yeah, I guess this is kind of what we have right now for the clutch. More videos will kind of follow as we go on. But yeah, what else we got in the chat? That's cool. My favorite is the SD10, the older 500. So you're you're a fan of the older 500 specifically. You're not referring to like the 500 SHTT like that, right? The Ray 2009. Sirens and fire alarms in Northern Florida. Mine is the Yamaha Music Siren and Thunderbolt. Yeah, the Yamaha's a pretty interesting one. I bet you all have seen the Dragonfly, maybe even Housefly, but you've seen it. Donkey. Shrek reference. Sirens, Aviation, and More. Hi guys, how's it going? I think you were in here a minute ago. Saw your Bell video. Sirens, Aviation, and More. Hi Connor. Yeah, how's it going, man? Welcome to the stream. I'm listening to your stream like a podcast, playing my game. It's interesting. Yeah, thanks, Abel. Yeah, that's pretty much what I intend for my my streams to kind of be viewed as, is not necessarily to be sitting down like just watching it. Unless you're really interested and you want to kind of see what I'm doing. I do have the other stream that I use pretty much just for teaching. But yeah, but basically just to listen to me ramble kind of in the background is kind of a fun thing to do. So I just hope you guys enjoy. I think this is pretty much a good little test. This would be a good little test rig to see kind of how it works. Again, I am concerned about this clutch snapping, and I don't like how close this edge is to the outer edge of this rotor of the center of the clutch. It's half a mil. That's really, really close. Whew. Man, that's close. That is really close. Which is a plus, because that means that the pawls themselves, the pawls themselves and the clutch don't have to spread out very far in order to catch the edge of the dog on the rotor. So yeah, that's gonna be really close. It's gonna be really tight, but we'll see if that actually kind of works. I'll probably see what this is going to look like when I print. Let's get rid of the rotor first so I can see kind of what's going on. Clutch pawls is its own entity. Is it combined on this part? I don't think it was in this model. Go back and delete this. Yes, remove it. Thank you. Okay. So let's update that again. Yes, it already exists. I know it already exists. Whoa, what is this? Dude, that is so cursed. That is cursed. What if we make an STH10? As I said later on or earlier on in the stream, I do plan on making an STH10 at some point because I've already made the STL10. So, if you're not a subscriber or you haven't seen the video, I've already made an STL10. So an STH10 is at some point coming down the pipeline. Can you do a gaming stream with me or only Siren streams? I mean, I probably can do a gaming stream, but I don't think many people will watch it because most of my channel is pretty much Sirens only. But yeah, I definitely probably could. Yeah, he made an STL10 already. Yeah, exactly. Sirens Aviation and more. BLB. I'll link in the chat. Oh, hey, I appreciate that. I appreciate that. Sirens Aviation and more. But yeah, I was it might be up there. It might not. I think it was a YouTube short that I might have posted it in as. That's probably why it didn't come up very quickly. But what was I doing? That's right. I was going to slice this and see if it's going to slice correctly. Let me make sure it's nice and small. So let's put this clutch in here and see if it's going to be modeled correctly. God, stop opening Q2 box. Just grab the thing. Thank you. I don't want to open Q2 box. I mean, I guess I'll leave it open since it's already there, but this is the main focus here. Is this going to work? Is this going to work? I really hope it does, because that'd be super cool. It'd be super, super cool, because clutch actually works the way I want it to. The one thing I also don't like about printing stuff with PETG filament is that it's PETG, especially on my printer, it just... things that are round tend to not be balanced very well. I found that's mainly, if people are wondering, why most of my Sirens are all PETG printed, so like a regular plastic, or like traditionally 3D printed. And then I print the rotors in resin or MSLA printed, is mainly for balancing, because the MSLA printers are just so much more detailed and just more accurate to the model I actually make, that they're pretty much balanced right out of the print, right off the printer. So I don't have to sit there and have to like make sure it's not going to vibrate itself to pieces. But the problem with regular printed stuff, like on the traditional printer, is that I've always found that they tend to be a little bit off balanced, especially for the really, really small stuff. Maybe not so much once it gets bigger, then it's a bit more uniform, and the little tiny inconsistencies in it really don't matter. But at the really small scale, the balance is really, really important, and I find that it ends up being kind of a pain. I also have to consider, I don't want this wall right here to be so small that once I press this onto the motor shaft, I don't want that to end up like being split because I'm forcing it onto this motor. I think this motor is actually damaged. But yeah, so we'll see what we can do with that. I'm going to print these up today, or tonight, and I'm going to see if this is going to work. You might see that in a short coming up on the channel once the stuff is done printing, because it's going to take about, I think, probably a half an hour to print this kind of stuff. I'm going to print it on both the MSLA and the FDM, so I'm going to print both of these, and we'll see which one is better. This is going to take a significantly longer time, at least 10 minutes longer, and we'll see which one's better. And then I'll show you a video if they actually work or not. But yeah, let's go ahead and get back into it though. So we'll finish on working the rest of the model. So we kind of have this now. So now it's time to start on the actual rotor itself. Let's get to the rotor. We're gonna delete, or we're gonna make the other stuff invisible because we're not working on that stuff now. So now let's get into the actual, not the engineering, but the actual modeling. So we're gonna try to We're going to try to model the rotor itself. So we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. This is not 26 ports. I know it's not 26. This is like what? Like how many ports? Does anyone actually know in the chat how many ports the Q is? I've never actually counted. I have never actually counted how many ports are actually on the Q. I think it's what I'm looking at here makes me think it's a 13 port, which is kind of an odd number. Literally an odd number, but I never actually counted. That's interesting. That's kind of important if you're making a model siren. Yeah, there's no way there's 26 vanes in here. These vanes, there's 2 vanes per port, so yeah, it'd be like 13. That's a lot of ports. 16, yeah, that's what I was thinking. I thought it was 16. I'm pretty certain it's a 16 port siren. I don't have one, so I can't just like go look at one. My voice cracked there. Like I said, my voice is getting all messed up now. I don't have one. What else is on here? So, what if you printed a Model 20? Are you referring to Federal Code Model 20? I think specifically, or like, are you thinking of like the Model 120? Because if you're talking about the Model 120, I think you've already seen it, but I've already made the Model 120. Can we do a stream when you're down here together? Yeah, I'm probably gonna end up bringing my laptop to do some siren work when I'm back home. So if you want to be in the stream, definitely. I'm also gonna be shooting some siren videos. You guys can, so you'll probably be there to be on there with me, Abel. Because I'm bringing my GoPro, because I'm going to be filming some stuff with Eden. What about 2T22 or 3T22? I want to make one in the future, but it's right now, because I love using these little motors, these little RM130s. You can get double shaft versions of them, but the double shaft versions are they're not long enough to make both the rotors be spaced out enough to make it accurate. So I just haven't done it yet, just because I want it to look really good. Is pretty much the main thing. If they were just like a little bit longer, then I would have probably made it 2T22 or 3T22 already. True. Sirens, Aviation, and more, and we have BSP making a music siren. He is? That'd be impressive. I mean, it's not that hard. I mean, it's just a whole bunch of rotors. It's the timing and having them tuned right that's the more difficult thing. Yeah, music siren would be kind of cool. I would love to see that once he actually gets it done. Sirens and fire alarms in Northern Florida. I'm working on making a wooden full-size music siren. A full-size music siren? I mean, okay. I mean, that's big. I would be really curious to see it, but that's okay. Sirens, Aviation, and more. How in the world do you even do exactly? My thoughts exactly. I'm like, dude, that's gonna be huge. But what would control its notes? Must be a metrical magic. 16, I think. Yeah, like I said, I think it's 16 port. Yeah, 16. My voice is dying right now. My voice is dying right now, dude. It keeps cracking and about to hit lows. Yeah, my voice is. I've just been talking continuously for such a long time. I don't typically talk this much, so it's kind of just like getting really gravelly. So we're making it 16 ports. Okay, so so let's start cutting some ports. Which ports are not the fat lady. Bring the cat back. Yeah. Yeah, lady. Yeah, lady. You guys have probably seen her in my previous video I just did recently, but here's my cat. For those who are wondering what her name is, it's Lady.
She's flea-ridden.
Yeah, she's flea-ridden now. We found a couple fleas on her today, so we gave her a flea bath, so she's all nice and clean. Ooh, you smell good. You smell like a cat. You smell good. Now she's gonna sit here on my lap. Yeah. What are you doing, honey? Yeah, that's my cat. That's one of my cats. I actually have 3 cats. But anyway, let's get back to the task at hand, and that is cutting the ports in this rotor. So, I'm not going to bother the stator. Stator's really easy stuff. That's not going to take that long at all. But the ports are another story. Did you hear her wheeze when you picked her up? My cat is so fat, so she like wheezes when you move her. So let's go construct. We're going to construct a plane and a tangent because we're making off this round thing. What did I just do that for? Okay. So we're going to do that. Come here. Now we can sketch. My voice is doing it again. Like I said, I've been talking for so long, guys. My voice is like... So, again, we're going to start construction on this. Let's get these ports cut. No. Why did I make it a circle? I'm a moron. Go here. Rectangle, 3-point rectangle. I like using 3-point rectangles because it allows you to kind of... just make them a bit easier, the ports. I'm going to set up some guiding lines here really quick. So I'm going to make each port about, 4 millimeters? About 4 millimeters, which is not super big. But they don't have to be super big. She is so whiny. My cat is not happy that she got a flea bath today, so she is just crying.
Stop having fleas then.
Yeah, stop getting fleas, cat. Which is odd because she doesn't even go outside. She's inside all the time. So we don't really know where she got them from. We're gonna make this port. This is 2 millimeters. 2 millimeters from the bottom, I think, if I made this right. Yeah, I think it's like 2 millimeters from the bottom. So let's do that. Now I've got 1 port. So now I should be able to just pull like that. That'll cut 1 port. Am I right on the bottom? I might have cut it too deep. No, I didn't. Cool, I cut it like perfectly. Oh, 10 o'clock. 10 o'clock for me here, so it's getting late for everyone else too. But luckily it's the weekend, so hopefully no one else has got anything else going on. So we're going to cut that 1 port there. That cuts nice and clean. Look at that, I'm actually a little bit off the bottom. Let's go back in and clean that up a little bit. Make that a bit closer. Make it flush. Try to make it as flush as possible. So I'm going to leave that. So now I've got 1 port. I know it's open at the top. I'm doing that purposefully, trust me. I have good reason as to why I'm doing that. Pretty much just because of the way that I'm going to be printing this rotor. I want to leave it open up there so it doesn't have to try to bridge that. It'll save me a lot of headache later on. So now I've got 1 port there, so let's go and create another circular pattern. Now we'll take that feature right there, and we will do the same thing again, rotate around an axis. So we've got 3 if we want to make a German a German siren, make it a 3-port. Let's do 16 ports. Let's see kind of what that looks like. Yikes. Yeah, that's gonna be real weird. You sure? Are you sure it's 16 ports? Am I being punked right now? I don't think it's 16. It actually might be less than that. That looks like a lot of ports. I can't believe I don't remember how many ports a Q is. And maybe you're right. Maybe you're right. Maybe it is 16. It looks like a lot. It looks like a lot. I don't remember. I haven't... And it's a DC driven siren, so that you can't really go off of like motor RPM and then the tone to figure out how many ports it is, because the motor speed for the siren is different. I don't know how fast the DC motor goes. Oh, okay. We're putting flea medicine on my cat right now. I was trying to figure out what my wife was pantomiming towards me. But that That's a lot of ports. Okay, so now it's trying to draw the fan, the actual blade shape. Now the Q, I will have to give credit to Federal on this one for actually making the Q have a directional rotor, which is like one of the only sirens they've made that actually had directional rotors on it, which is really, really cool. I mean, early on for the Q, because the Q's been around for a while, but the Q was really one of the first sirens I've ever seen that Federal's made that actually had a directional rotor on it. So good on them. I mean, B&M was doing it a long time ago before that, but we're not going to talk about that. Bless you. And on this Q, it splins I'm tired, guys. It spins counterclockwise, but on this, because I know which direction my motor's going to be spinning, we're going to be spinning clockwise. So if you're going to be making a big fuss about it not spinning in the right direction, then that's too bad. That's too bad. I know there's quite a bit of an interesting overlap with how the Q... I keep forgetting where I am. Where am I? Let's get rid of this. Yes, quit. Quit. I know there's kind of an interesting overlap with how they did the Q. So each port come out there. It's about half down. Okay, that's like one of my impellers I just made, actually. That's kind of interesting. I just made an impeller for something I'm working on. I'm not telling anyone what it is because I want it to be kind of a surprise. But I'm working on another siren besides this. But this is it's a fan for something. Let's just say that it's a fan. I mean, well, I just gave it away, but it says up there: small, high volume, intermediate pressure blower. Now, what kind of siren do you know that uses a high volume, intermediate pressure blower? I wonder. I'm just screwing with you guys now at this point. I'm just excited about it. I don't know. I'm just excited. So now let's go ahead and start drawing the fan, or the actual blades of the impeller, the rotor. Excuse me. Where is I just gotta make a sketch. There we go. Fit point spline. Once I do it once, I should be able to do it again. Pretty easy. Okay. So we're gonna come off of this edge and about right there, and then we're gonna start bending down to about right here, I think. Because it has a very, very smooth kind of sweep to it for the Q. That looks better. That looks a lot better. Yeah, that's got kind of a really, really cool little sweep that the Q does. I love the Q's rotor design. It's just a really pretty looking rotor. Okay. And we'll do another fit point spline on this edge, if we can find it. There we go. To about right there. There. That's gonna be a thick freaking vein. I don't want to make it that thick. Let's go from right there. Okay. Make it a little bit thinner than that. It does not need to be that thick. Okay. My wife is putting flea medication on my cat right now. Okay. And there's one vein, which is a bit thicker than I kind of want it to be. But we'll see what this looks like once I put a whole bunch of them in there. Yeah, it's a little bit thicker than I want it to be. Lady, hush. probably can hear my cat kind of quietly complaining in the background. Let's make this a new body so I can just have one of them right there so I can move it. Let's try making a pattern. Let's see what it looks like. Let's see what it looks like. 16 of them. Oh wow, that looks weird. That looks so weird. And I also made it go in the wrong direction because I am an idiot. I forgot, again, this rotor spins clockwise, not counterclockwise. But that's what it would look like. Kind of. Yeah, I mean, this is really thin, but again, like I want to make this rotor kind of heavy. The one problem is I have to make it heavy, and I have to make these vanes thick enough that the printer can actually print them. But I also have to make sure that there's not so much space taken up by vanes that it can't actually pull any air through it. So there's a lot of things I have to kind of consider when I'm doing this. I know it's probably 7 o'clock now in most places right now. Well, 7:08 because I'm going on a little late. But I'm going to read a little bit more of the chat really quickly. Nah, man, your voice is fine. I appreciate that. Yeah, the chopper's a music siren is the size of a Model 5. What? You sure about that? I think the diameter of the chopper is the height of the 5? You got me confused now. Sirens and aviation and more. Now I definitely know you're not making music siren. You don't know what siren I'm talking about. But I don't know if I'm ever going to make a video of it. Qs are 14. That's what I thought. I thought they were 14 port. Like 16 seems like quite a bit. Because that's the point of making them. Because what's the point of making a music siren when I already own a Bosai Musen? Oh yeah, that's right. I remember you talked about that in the last stream. Sirens and fire alarms in northern Florida is fighting with sirens and aviation and more. We have a fight in the chat, guys. Sirens and fire alarms in northern Florida. For some reason, I want to buy a Q now. Yeah, Qs are really cool. I mean, they're an interesting one, but I like I like Qs, but I am partial to B&M because I mean Qs. I don't like that modern Qs nowadays are made in China, or at least a whole bunch of them, or a lot of the components of them are made in China. I think the motors are made in China specifically, and I'm not a big fan of that. Whereas all the B&M sirens that you can still get are still made in America. Every single part of them are, including the bearings, which is surprising because I mean, as a guy who does HVAC, trying to find a bearing that's made in the United States, that's impossible nowadays. Sirens, aviation, and more. Model 120. I've already made a Model 120. AJ, Model 120 2.0. Yeah, that'd be kind of a cool idea. I mean, it'd be kind of fun to try to make one a bit smaller, and try to make one kind of like in the same scale as the like the STL10. That'd be a lot of fun. Try and make another Model 120. I made like a really big Model 120, but I made for Aaron. Aaron or Dubrox 5539, I believe is his channel name. He owns it now. I gave it to him because there was no way I was gonna be able to take it all the way across the country here. So Qs are expensive. Yeah, they're about almost $2,000. Unless you whip one off a truck. Yeah. They are only 24 volt and they are so expensive. They are 12 volt. Then it's free, plus a felony. Yeah, you get the felony for free as well. Good idea. I'll go to junkyard. 24 at over 100 amps. I'm pretty certain that they're 12 volt. They're all 12 volt. They just use. I mean, unless they've got them now that you have dual voltage, because I know that most of the truck voltages on fire trucks now are probably 24 volt because they use 2 battery systems. So it would make sense, but yeah, 24 volts at over 100 amps. It still pulls a lot of power. Yeah, it's a huge motor on them, so it makes perfect sense. Y'all, I'm about to doze off. Alright, Sirens, Aviation, and more. I guess I'll talk to you later again, sometime later, man. I mean, if you end up missing anything, you can always catch the stream or start off where you pretty much left off if you want to see anything else. My outlets in my house have plenty of amp. The outlets in your house are 15 amps. Depending on where they are. If they're in the kitchen, they're probably 20, but most outlets in your house are rated at 15 amps. Alright, good night. Yeah, good night. Alright. Puts a fork in an outlet. Outlets are, number one, outlets are AC, Qs are DC, you'd need a rectifier. Two, most outlets in the US are 15 and 20 amps, 115 volt, yeah, exactly. Alright, Abel. Alright, Abel, I'll talk to you probably sometime later, dude. Good night. Oh, it's not a fight, we're friends, bro. Alright. Ah, so 12 volts at 100 plus amps. Yeah, I just know they draw a lot of current. Yeah, but as far as I'm aware, a majority of the stuff on fire trucks they're all 12 volt. Like there's probably, I mean, even though fire trucks do have dual batteries because they need a lot of cranking amps to actually start the truck engines and also just to run the auxiliary stuff. Because the starter on a diesel truck is usually 24 volts because it doubles both the batteries, but pretty much everything else on the truck is usually 12 volts. So, all right, so let's kind of continue on. I had a feeling that it was 14 ports and not 16, but I listened to the chat. What can I say? Well, it's also kind of my fault for not just knowing this by heart. I should just know that. But I should just know that. Yeah, 14 ports. Okay, that makes more sense. Yeah, that makes a lot more sense. Yeah, you're right. It's definitely 14. It is definitely 14 ports. I don't know what I was thinking. Alright, so let's make that spline, or that fit point spline again, so that makes those little legs, those little, these little things right here. I gotta make sure I spin the right direction. I keep messing myself up and trying to go somewhere else. I'm just so used to drawing these splines off of this edge going down that I'm just like so just accustomed to it now. Put one right there. Put one right there, and we'll gently. Nah, it's too far out. Bring it in a little bit. Put one right there. And we'll put it right against that edge. Man, I'm still like thinking to myself, like that's crazy. We had Tyler in here. We had Tyler in the chat. The OG. That's just really cool. I am flattered that I had Tyler in the chat. All right. Let's see kind of what that looks like. Okay, we'll extrude that a little bit. The Q's, yeah, it's got a little bit of a divot in the center. Okay, I didn't even consider that. Yeah, I didn't even consider that. I might have to make that in just a second. Let me go, first, I want to make all these line up and see kind of what this looks like, and then I have to make the rest of this to make it look accurate. Let's see how that looks. How does that look? It's not pretty. It's not pretty at all, but we're getting there. This curve is just so smooth on this. I would love to get that looking correct. It's done just so smooth though. Yeah, let's back that up. That doesn't... I'm just not super thrilled with how that came out. This is a lot, again, this is a lot of like kind of what you end up doing in Fusion is you do a lot of like little tiny things to trying to just get it perfect. No, another one. I'm gonna do like right there. Then another one. Then another one. That looks better. That looks a lot better. Okay, finish that. Focused. Sorry, guys. Just being quiet because I'm kind of trying to pay attention to this right now. Again, I'm not usually used to modeling these with an audience, I must say. So you'll have to excuse me. Okay, that looks pretty good. Yeah, that looks pretty good. Make sure it goes all the way to that top edge. There we go. Don't want to join it. Make it a new body. Again, that looks pretty good. That is nowhere near lined up correctly. Well, let me rotate this just really quickly. Yeah, that was my fault. It should be lined up like that. 15 degrees, 14 degrees. Nope, 13. There we go, 13 and a half. Does that clean up that edge? Does that edge line up? Oh my gosh. 13.8, 13.7, 13.6, 13.7. That's perfect, right there. Okay. So now we can go in, pattern, do this around this axis 14 times. Okay, now we're getting closer. Now we're getting closer. And then now we get rid of the rotor. Because now we have to make that little dish shape that's kind of on the Q, on all these veins. So we'll go to the chamfer tool. I probably should have done it on just one of them. Let's do that first. Let's do it to just one blade actually first. So we'll get rid of the rotor. This is the thing, this is something you guys are gonna like, because you're gonna see it's gonna make a really funky shape. So here's that one little vein out of the Q. So we'll go to fillet. This will allow us to make this really wicked little like smooth curve on the top. You can see just like that. So the Q is pretty got a pretty wicked little curve going on. If I can make this tangency weight just a little heavier. I don't know, a little lighter actually. So we're going to do like say 0.8. 0.5. 0.4? Let's try that. Yeah, I'd say 0.4. 0.4 looks pretty good. Okay. Bring the rotor back. Okay, so now we're getting more of that smooth transition up toward the actual edge of the blade is. So now that we have that really complex little edge done, now we can go back in here and then make this circular pattern. I'm not selecting a feature, I want to select the body. There we go. Axis there. 14. There we go. Now let's again, this whole center section unfortunately is going to just kind of have to stay there because it's doing so much work on the inside to actually hold the whole clutch. Again, realistically, I probably could shave down this edge just a little bit, but I don't want to remove too much material to end up making this too weak along that edge. But I could do something probably like that. I mean, that kind of works. I could do that. I'll do that. That looks pretty good. So there we go. There's kind of our version of the Q's rotor. Of course, again, spinning in the other direction, and they don't have the actual top little ring going around it, which I have to add because it's not gonna work right if I don't have that ring. But that's it so far. So that's what we kind of what we got. I will definitely spend some more time. Oh, did I lose internet? Hope not. Hope it didn't kill Streamlabs. Also, pro tip: don't stand next to a queue without hearing protection, like I did at a parade. You're still ringing this day. Yeah, it will give you some pretty bad tinnitus. How would you guys rate an MS390 120 volt 1 out of 10? Me personally, I'm not a super big fan of the Chinese style sirens. I don't like that they use universal motors. I wish they just used like regular induction motors because I think they would just sound so much cooler. Because they actually would have that distinct wind up, and then they would reach pitch and they'd stay there. I mean, they're cool. I think they're pretty cool for like if you want to have a siren that you just want to put outside and like let get kind of rusty and kind of like rot. Those are super cool to put outside. But like a Model D or something like that, something you kind of want to keep in really good condition. That kind of stuff I keep inside, and then basically just test it whenever I want to. My cat has come to. My cat has come again. But they're pretty good. They're pretty good for like beater sirens, I guess is the way I can say it. Also, quick question: what part of northern Florida are you from? If you don't mind me asking. I'm a Southwest Georgia enthusiast. Milton, Santa Rosa, with E classes. Oh. System had an electronic 7000s, but were replaced in 2010. Wow. Went to Pensacola not too long ago and passed through Milton. I only remember seeing DSA 60. Yeah. So yeah, it's you guys. There's a lot of interesting sirens around here. It kind of sucks because the only stuff I've found, at least you guys are talking about Georgia and like Pensacola, Florida, but like the stuff around here, because I live in Columbia, South Carolina. Some of the stuff that's around here, really all that I've found that we have, is we have a couple of DSAs out by the river. I actually heard one of them doing a silent test recently. You could walk up and hear the radio, the tones come in. I could hear the radio, but that's pretty much about all I have near me. And then I have there's a 2001 130 DC or 2001 130. Also by the river as well. That's used for like high water. It's a high water alarm. Let's see if I actually have the the video of what the tone sounded like. It was kind of cool listening to having the tones come in. Where is it? Yeah, here it is. But yeah, those were the DSAs by the river. They were doing I think they were either they were trying to actively test, because it was around the test time. It was like 12 something, or like no, it was like a little bit after 1. So they might have been trying to test, and honestly, I wouldn't be surprised if the drivers are just dead on them, because they've been out there for a long time, as far as I know. Drop my pants on, I got the hotel back and try to get a picture too. That's funny. USB siren that will have a long coast, definitely buying. Yeah, that's the whole intention. That's kind of what I'm trying to do, at least. I never really studied the Q. How many ports is it? I'm assuming 12. I think we've pretty much have deduced that it's probably 14 port. I thought it was 13 port, because looking at the rotor here, the way that the vanes are set up. I wish I could zoom in, but the stupid work point is such a pain to work with. But I think that the way that they did this is that the inside of this port right here, so basically the port, those vanes create the wall channeling into the port itself, and then you can see it goes down and then it opens up to the port right here. That we've got 20. I counted 24, I think. Yeah, because there's 2, 4, 6, 8, 10, 12, 13, 14. Yeah, it's 14. It's a 14 port. Yeah, it's 14 ports. Definitely 14 ports. So there's the rotor so far. So I want to go, actually I think what I want to do really quickly is I want to go back very, very briefly, and I want to kind of fix that. I don't really like that, how far it kind of extends. I might want to go here, chant for this again, no, fillet this again, and let's make their takeoff weight a little bit less, a little bit more. So I do have to put this little ring around the top of the siren eventually too. Around the top of the rotor, I should say. 9 millimeters. 8.5? 8.5. That's a little big. 9, 8. Let's see. Let's do 8. I mean, yeah, let's do 8.5. 8.5 seems good. And then make this takeoff weight a little, or tangency weight. I keep thinking of like making splines or sweeps. Let's make our tangency weight a little bit different. Let's go like, I think I did 7 or 6. I did 5. Did I do 5? I think I did 6. That's pretty good. Yeah, let's keep it there like that. So 0.1 seems like quite a bit. Let's do 5 like it was. No. 1 just does look better. It does look better. Yeah, okay, so just 1. Okie dokie. So now I can go back again. So I keep changing things. I keep changing things. I like kind of like fiddling with it and making it like as close to perfect as I possibly can. Even as a prototype, just because it saves me time in the long run, because I don't have to go back and like try to fix it again to make it look just perfect. I can just kind of just do it here like the first time. It saves me a whole bunch. Let's clean up that edge again. Yeah, that looks pretty good. That should be pretty good, just like that. Alright. Okay, so now... Yeah, okay, so now it extends in quite a bit too, so now I should be able to come... Oh, I have to modify, I have to connect all this really quickly. I have none of these saved first. I haven't saved this entire time. I just realized I haven't saved any of this. So we'll save this really quick while I still have internet, because I don't want internet to just die all of a sudden. And we can drive now? Sweet. That was not there before. Now I can combine all of these. Actually, you know what I can do? Cheat. Just highlight the whole thing. Oh no. Oh, I thought it crashed Fusion for a second. I was about to have a heart attack. Please. There we go. Sweet. Alrighty, so there's the rotor for the Q. Chonky, dude. A very chonky looking thing. And we'll go in here. Go to sketch so I can create another circle. Center circle right there, all the way out to the edge. And then come in to right there. Now I should be able to come here. Press pull all of that to make that a little bit thicker. Let's go up 1 millimeter. Yeah, it's a bit of a weird Q. Again, as I said before, it's a bit of a weird shape just because I'm kind of going with the constraints that I'm stuck with the scale I'm at. So some changes will have to be made just in order to kind of make it work the way I need it to. But there's basically the little Q rotor, and then with all of the guts on the inside for the clutch. For my little version of the clutch, at least, I'd be really curious for it to work correctly. And I did purposefully make this back section right here, this back base that the whole rotor is kind of constructed around. I purposely made that pretty thick so that if I want to, if this clutch holds up like I hope it does, I can add a weight to the rotor too to make the rotor heavier so it can wind down even longer. But again, it all depends on if it's actually going to work or not. It all depends on this clutch actually functioning properly. So that's pretty much about it for today, guys. It's been going on 3 hours now, so it's been a really long stream, but I appreciate everyone for kind of coming in and joining. Sorry for coughing so much. Again, my throat is so dry. But yeah, I hope everyone kind of enjoyed the stream, kind of got to tool around me and see kind of what I was working on. But if this all works properly, I will definitely have a YouTube short, or probably even like a longer format video kind of going through to see people can kind of see how it ended up working out. But yeah, I appreciate everyone kind of watching the video and sticking around with me. It was a lot of fun having everyone else in the chat. It was a lot of fun just kind of talk to everyone, and yeah, I'll also like the interaction. So, but yeah, hoping to see this actually work out, because it'd be a lot of fun to have a little small, cute desktop little Q that actually works and coasts. It'd be really, really cool to have. So fingers crossed. Fingers crossed that it comes out perfectly. Let's hope that my engineering skill can kind of make it work right. How much is it? How many decibels is a Q at 10 feet? I think it's like 100 something. I think it's like what, like 112, I think, or like no, like 110. I think it's 110 decibels at 10 feet. But yeah, so that's pretty much gonna be about it, guys. I appreciate everyone watching. I guess you really can't comment, rate, and subscribe to this, but you can at least, like, you know, look at the chat and stuff like that and have a laugh. But yeah, I guess I'll catch you guys in the next video. I hope everyone has a good night as well, because I know it's pretty late. It's 10:37 for me, and I'm getting hungry. My throat hurts, and my cats want me to go out and actually probably feed them too. It's getting really late for them. Good night, Connor. Thanks, Tyler. He returned. He returned. Yeah, I'm gonna get some sleep. All right, guys. I'll see you.